Coffee stains and my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
What up, what up? Taj, what's good? How's the audio? All right, let's get it. Coding interviews today. I already got somebody waiting on me, so we got to start up right away. Taj, what's up, man? How you doing today? What's up, man? How's it going? Oh, hold up, hold up. Yo, what's up?
Hello, do you hear me?
Yeah, what's good? How you doing?
Good, good. How are you?
Pretty good. Have you done a coding interview here before? Or is your first time?
Yeah, first time.
Oh, nice, nice, nice. Cool. Hold up. Just setting up real quick.
Yeah, yeah, no problem.
What brings you here today?
Just prepping for interviews. Yeah, I'm trying to get better at articulating my ideas.
Nice. It is the perfect place. Have you seen the videos before? Like the mock interviews for a while, or just tuning in for the first, or you just started tuning in?
Yeah, I like watch some of your videos over summer
Nice.
and then signed up. Yeah, I was bad at during summer, but I practiced now. I
All
feel
right,
a
let's
little
see
bit
where you're
more
at.
confident.
Let's get it. Hold up. People are just, stream is rolling in. Yo, Paul, what's up? Hold up. Give me a second, just setting up.
Yeah, yeah.
I'm gonna send you a coder pad.
Okay. In the
In
Google Meet?
the in the Google Meets.
Okay,
Let's
bet.
see. Holy, it's hot right now in SF. I'm sweating, but I don't want to turn the fan on because it's loud on the mic.
You live in the South?
Yeah. Where are you based? Texas?
Yeah.
Nice. Oh, it's probably hot there too, right? Or not
Oh,
yet?
yeah, it's like 80, 90 degrees.
Damn. Or I mean, it's gonna get cold though. Or no?
Yeah, it's like very good during December. It's like 40, 50.
All right, I'm gonna send you a link.
Okay.
Sec. Hold up. Let me grab something. Just get in there quick.
Yeah, I think I joined.
Nice. B man, what's up? have to crack the window quick. All right. One second. B-Man started a leak code club at the uni. Bad. Appreciate you. All right. Okay. Let's see what we have here. All right. Hey, everyone. We have a student from Austin, Texas. UT Austin solved around 150 leak code questions. So what year are you in university?
Yeah, what's up? I'm a junior.
Junior? So third year?
Yeah, yeah.
So how are you with leak code?
Um, I started this summer.
Nice.
Yeah, and I'd say I'm not that good. I'm keep. I'm trying to practice more and more.
Yeah. So what concepts can I ask you? Are you good with? How are you with trees and graphs?
Yeah, I'm comfortable with those.
Nice. What about arrays?
Yeah, that's fine too.
Nice. So what kind of jobs are you looking to land?
Mostly like SWE or ML, data
Nice.
science, like look at everything.
Yeah. Are you having trouble getting interviews or no?
Yeah, kind of. I applied to like maybe like 200
200?
and didn't get any. Yeah, I didn't get any interviews yet.
Okay, that's quite a lot, but I'm sure you'll start getting some because you're in your third year. You'll be
Yeah, I
good.
hope so.
Do you care where it's gonna be, or you're applying anywhere and everywhere?
Yeah, anywhere, remote,
Nice.
you like any city.
So what companies did you apply for? Are all the companies out now? I haven't even checked, so I don't know what like who's hiring or
Um, yeah, most like FANG companies are already out. Like all the unicorns, Notion, LinkedIn, Databricks, they're all out.
nice,
Yeah, I don't know what other companies are there left.
nice. So you applied for all the fangs, all the unicorns, everything.
Yeah.
Nice. And what's sort of the process that for all those companies this year?
Uh, so just an application, then there's often an OA. I had an
Yeah.
OA for Google, and I'm still like waiting for them to reach back.
Hmm.
Yeah, but I didn't get anything else from other companies.
So all companies are pretty much still asking leak code these days. That's still the process.
I believe so. Yeah.
I see. Cool. All right. Let's hop into this interview then. We're gonna be working through 1 to 2 questions. We're gonna spend about 20 minutes per question. So
Okay.
yeah, let's see how you perform.
Okay.
So I'm gonna give you the first question. What language do you like to use?
Python.
Python? All right. All right, this is the first question. We're going to be given an undirected tree consisting of n vertices numbered from 0 to n minus 1. Some of the vertices have apples, and we need to return the amount of time it takes to collect all the apples in this tree. So that's what the question is at a high level. I'll let you go ahead and read the question. There's a lot to it, so just take your time and let me know if you have any questions.
Okay. Yeah. So it's undirected tree and vertices. Some have apples, some don't. 1 second to walk from over one edge.
Yeah.
And we need minimum time in seconds to spend and collect all apples in the tree. Starting where is zero and come back to this vertex. Okay, so we have to come back. Okay, and the edges are undirected. So given AI, BI, there's an existing edge connecting vertex AI. Addition, there is a Boolean array as apples, where as apple I equals true means the vertex I has an apple, otherwise it doesn't have any apple. Okay. So we have to also come back Interesting. Okay, and are there like any examples, or I have to come up with my own?
I'll give you one example.
Okay.
So here's one of the examples.
Mm-hmm.
So there's also a drawing if you want to draw it out. I'll post the example in the drawing. Or yeah, in the drawing mode, the whiteboard.
Oh yeah, I see. Did you paste the drawing?
Oh, you don't see it? It's in there.
Like I
Maybe
see input, output.
yeah, that's pretty much the input. So I mean, I can draw it out for you.
Oh,
I can draw it
oh
out for you
no,
if you
no,
want.
it's
Okay.
chill, it's chill. I can do it.
Yeah. So these are the edges. So edge. So the first element shows that there's an edge from 0 to 1, and then there's an edge
Okay,
from 0 to 2, then an
okay.
edge from 1 to 4. So draw it out, and like you can color each node that has an apple with a green, and then we'll figure out from there why the output equals 8.
Okay. So we have
Yo,
no.
MX was good.
Oh, so hard. Okay. Node 0. There's the edge to node 1. So there's also edge from 0 to 2.
Yeah, it's gonna be a tree, by the way,
Oh, okay.
if that changes
And
how you want to draw it, but it's fine.
yeah, lucky. I'm gonna draw it real quick. So there's 1 to 4, 1 to 5. 2 to 3. 2 to 6. And the edges, so which ones? 1 to 4 has an apple. So I'll just mark it like that.
Well, or no, it says like for each index here, that's a node. So this is node 0. Node 0 doesn't have no. Yeah, this
Oh,
is node 1, node 2.
yeah, my bad.
Yeah.
Okay. So,
So here, node 2 has an apple.
mhm. Yeah, so I guess I'll just node 2 has 1 and node 4 and 5. Okay.
Exactly.
So we start with node 0. Then I guess we explore one of the paths. We go to node 1, check its children. So we have to collect 4 and 5. That's what. So we went from, that's 3 sec. No, we also, okay. So 0 to 1 is 1 second.
Yeah.
1 to 4 is 1 more second. I have to go back,
Yeah.
which is 3 seconds.
Yeah.
Then to 5 is, so 4. Go back to 1 is 5. Go back to 0 is 6.
Mm-hmm.
Then go to 2, which is 7. Go back. Okay. Yeah, which gives you 8.
Yeah.
Interesting. And we are given just an array of edges. Okay. We have to collect all the apples.
Yeah, exactly.
Mhm. Mhm. Yeah, I guess it's some kind of like in-order traversal. Oh, but is it, they want the minimum, right? Oh, yeah, the minimum time. So if 4 didn't have any apples, then there would be no point in like wasting 2 seconds. going
Yep.
there and back.
Exactly.
Okay. So I have to somehow determine if I should explore that path. Hmm.
Christian, what's up, man?
Okay.
Yep, exactly.
Mhm. Yeah, I'm just trying to think. Yeah, and here, for example, when I was at 2, I knew that I'm done exploring all the apples, so there was no point in checking 3 and 6. I just went back. So I need to track all the apples that are collected.
Yeah, exactly.
So it's
Christian,
probably I could store
congratulations
like
on
a
the Capital
variable
One internship.
of how many apples I've collected so far.
When do you start?
And I also can find how many apples I need to collect. Okay. Mhm. Yeah. Yeah, I'm just trying to figure out like in the efficient way of checking whether there's any point in exploring particular children.
Makes sense.
Yeah. Yeah, I was also thinking maybe it would be easier to just like iterate over the apples I need over the nodes I need to visit. But that would make sense because if I like if I like go from 0 to 4, it gives me 4 seconds. But then that's not
Mm.
the minimum because like when exploring 4, it's easier to go back to 1 and then to 5. That will save me more seconds.
Yep.
Okay. So maybe some kind of backtracking, like if I say node 1 didn't have any children that have apples, so the left subtree of 0 is like just like useless for us. So maybe I could have went and explored it, but once I realized there are no apples, I could like backtrack and subtract the wasted seconds. Or it's some kind of recursion. Mhm.
Hey, what's up, man? Thanks for tuning in all the way from Mexico.
Do you have any hints? um,
Okay, so
like choosing the paths.
yeah, so what you're thinking right now is you don't want to. You're saying you don't want to explore a path because it might be a waste.
Yeah,
What would be an example of that? Would it be something like
like if like look at node one,
okay,
and
what
right
would be
now
the
it's like
answer to
four.
this?
Oh, okay.
Right, what would be the answer to this?
So we would just go from 0 to 4, which is 2 seconds, back to 1, 3 seconds, check 5, 4, and then go back to 0, which is 6.
Yep.
Yeah.
Mm-hmm.
And we never visited the right subtree of
Yep.
0.
Do, yeah, but we would probably have to visit the right subtree, right? Just to figure out if there's any apples in there.
Yeah, yeah, that's true.
Yeah. Okay. So you mentioned.
So
So what are the possible traversals that you could conduct on this binary tree or this tree? You mentioned one of them.
like in order, pre-order,
Yeah.
yeah. So you're
So
asking what type of traversal is like fits the most?
yeah, just try to think through the different traversals and try to see which one would fit the most for
Yeah,
this problem.
yeah. It looks like the in order traversal because we like go left. Oh wait, actually, if one had an apple too, then I would check if one had an apple and then go left and right. So it's pre-order.
Or let's see. Let's create a very sim. Let's create let's work with some smaller cases. Let's just do like 0 here. Let's work with this small case right here. 1, 2, right? And let's just say
Mhm.
we only had this. How would you get the algorithm to work there?
Okay. Okay. So I mean, I started node 0. I check if node 0 has an apple in my has apple array. If it does have an apple, I don't do anything basically because it's a it's a starting point. Then I check the left subtree, check one. One does have an apple. So but I also have to like add the second I spend traversing that. Then I would go back to 0 and add one more second and then explore right. The 2 doesn't have an apple and it's a leaf node. So like I'm basically done traversing it and I would subtract the second that I added when visiting it, right?
Hmm.
Am I thinking of it in the correct way?
Like I'm not sure if you would need to subtract. So while you're doing traversal, you're adding seconds, and then when you realize the path doesn't exist, you're subtracting seconds.
Mm.
Is that what you're doing?
So yeah, but you say maybe there's no need to add seconds before I actually find like a apple. Hmm.
Let me think.
But if I check like for this, like if 3 had an apple on this subtree, then say I was exploring this, I would go to 2 and 2 didn't have an apple. I wouldn't like add any seconds. Then I'd go left and then I realize, oh yeah, it does have an apple. So I would need to keep track of the
Yeah.
number of nodes I visited, number of edges I like traversed.
Yeah. Okay. Try to think of a post order solution to this.
Oh, post order. Okay. Mm-hmm. So I'll check the left subtree, and I would like consistently write. Like I would do like a recursive post order. Say like check the left subtree, and if it returns something, like I don't know how many apples it visited, then I would add the time. But if like I check the right subtree and there were no apples in there, then I wouldn't even add anything to the time, right?
Mm-hmm.
Yeah, I think that could work. But I would just check if a particular subtree during that reversal I like encountered any apples.
And then
And then based on that, I would add the time it took to traverse it to the result. But
okay.
if there were no apples, I would not add it.
Yeah. How would that work on this small case right here?
Okay. So I'm at node zero. I would recursively call my like function on the left subtree. And I will check one. One is apple.
Sure.
So I would return how many seconds I spent finding all the apples in there. So it would be P1. And then, okay. I also need to account for the time going back. Mm-hmm.
So pretend this was marked. Would it change anything?
Uh, no,
It would change the answer? No.
I don't think so. Yeah, it would still be 2 seconds for this small example. Yeah.
Okay, let's try a different question. Let's move on to the next one.
Yeah, okay.
I'll post
Uh,
I'll
yeah,
post in I'll post in the next
struggling.
question. So we're gonna move on to Q2 just to make sure we get through all the questions, but we're gonna be given two strings, S1 and S2. Find out if they only differ by the insertion of a phrase. So for example, this one should return true. This one should return true because they differ by cute little. If you add
Mm-hmm.
that into T or S2, they equal the same phrase. So it makes sense?
Yeah. So by phrase, you mean just some sequence of words
Yeah,
separated by
exactly.
space?
Exactly.
Okay. Yeah. So I probably could. Okay. Let me just look at the second example. So we have the boy is nice, the girl is nice. So since this phrase doesn't have a boy in it, then it's not. So, but if I had a boy in here, then it would be true, right? Like for the second string, if I had a boy,
If you had where?
like here. Oh, you see it?
Yeah, then it would be the same because if you add girl there, but
Okay.
right now that returns false because there's no way you could make the two strings the same.
Okay, makes sense. So I could probably split the string by a space to just get all the words. If I like tried on this example, uh, I'll get like the boy goes to hospital.
Hmm.
I like basically the same thing. It's a cute. Well, okay. So say iterate over this longer array. You have like 2 pointers. Like say they all start at the first word.
Yep.
I would compare the words. If they're equal, then I can like move both.
Yep.
If they're not equal, I'm supposed to. So I, and the phrase is inserted only in one of the strings, right?
Yeah, you can insert into any of this. You should be able to insert return true if you can insert a phrase into any of the strings and then they become equal.
Okay. So that basically means that one of the strings has some additional number of words. So, and the relative order of the like remaining words is supposed to be the same. Then, like, if because I know that this is a longer array, then if they were equal by inserting phrase, like I knew that the phrase was inserted here, right? So I probably could keep moving this pointer until I find a match on the boy. And once they're equal, then and this the phrase that I'm inserting is like it's like how would I say it? So could I have something like this? If I had the little boy goes to the youth hospital. This is not valid, right?
What's not valid?
Like this would return false if I had these 2 words inserted.
Yeah.
Okay. Yeah. So I would definitely know by just skipping the pointer in the longer array, I would know for sure that I like skip the phrase. And once I have a matching words, I could just move them. And if I reach the end of that array, I should return true if both points reach the end. Let me try run it on this example. So the boy here's the girl. Yeah, in that example it was easier because this was a longer sequence of words. So like I knew that if phrase was inserted, it was inserted there. But now it's equal. So I guess I could just arbitrarily pick one. Like let's say the first like remain let's suppose. Oh, I guess if they are the same length, then the strings have to be equal. Yeah. So if I split both strings by space, they are the same length, then I would just check if the two original strings are equal, right? Because, yeah, I can't think of any other ways I could insert a phrase. Yeah. So I don't even need to deal with this example, with this case. So I would just check if two strings are not linearly equal, I would just return false in the case of equal number of words. Okay. Yeah. Yeah. Can I start like implementing?
Wait, what's your solution?
Yeah, so I first split the words by space, get like two arrays. Then I would handle first like this case. I would check if their lengths are equal. If the lengths are equal, I would return whether the original two strings are equal.
Okay.
Otherwise, I would initialize two pointers, both at the start. And if the words are equal, I move both pointers. If they're not, I would move the pointer like of the longer array. Because I know that we should have inserted the phrase there.
Okay. And like,
yeah.
What do we mean move the pointer? So if this is
Yeah, so like
yeah, can you explain that?
Yeah, so we have like cute and boy here. I would keep moving cute until I found a match on a boy. Once I have a match, I continue doing it. But if there was no match, I would just return it. Like if I reach the end of the array, I would return false.
Okay. So what
Because
happens?
this word is never matched.
What happens if? What happens if? Like once we've matched boy, what? Like, can you continue out? What happens with the algorithm?
Yeah. So if we match boy, our pointers are here, like at the second position, the fourth. I would just move both again. Or maybe there is. Yeah, I think I would still keep checking the other words. Even though I can insert only one phrase, I still have to make sure that the rest of the words are equal. Right?
What happens if this?
If this was like
S2 has extra Z there.
Yeah, so I would keep moving this.
Or why would we keep moving?
Because the second string, like the second array is longer, so if there was a phrase, it would be there, right? And so I could just move all the pointer to skip all the words that were that would have been in the phrase.
Wait, say it again.
I would have moved. I can move the pointer if there is no match, because if the phrase was in some, like if the S1 and S2 only differed by a phrase, like the phrase must have been inserted in the longer string, the longer array of words. So my pointer for the first string remains here, and this one just keeps going until there is a match, but none of them give a match to goes, so I reach the end of the array and return false.
Well, What if this was goes? I'm not understanding the logic. Like,
If
what if
this
this
was
was goes? Then do we actually want to match on that?
so oh, okay. So if this was, yeah, I see what you said. So that would mean like there was like a second phrase in between. Because once, okay, if I like my like if my logic remains the same, I keep moving my pointer, and I have a match on boy, then I can move both, and the rest of them have to be the same. Like all the words after the pointers. Is that right?
Yeah.
Okay. Yeah, that makes sense because my solution didn't account like having a second phrase.
Like the phrase needs to be inserted in the contiguous. It's a contiguous phrase. We can't insert a bunch of elements in between different words.
Yeah. Yeah, I didn't account for that. Okay. So yeah. So if once I once I'm done moving the pointer and I get my first match on the boy, I'll just check the remaining words. So it'll be like goes to the hospital and like goes Z goes to the hospital. I'll compare the two arrays. If they're equal, I return true. If they're not, I return false. Yeah. Can I start implementing or am I still missing some edge cases?
I mean, what if there's boy here? Does this should this return true or false?
Yeah, that should return true because I have a cute little boy goes C phrase. Mhm. Mm. Yeah, even though I matched on the first boy, that doesn't mean
Mm-hmm.
that this boy wasn't like a part of the phrase.
Mm-hmm.
So
Okay, I'll give you a hint. What happens? Okay, we have we have the two pointers. We see boy and cute.
mhm.
They have a mismatch, right? Is there a way
Yeah,
to move up the pointer in like move up the pointer in a smart way so that like where should we move this pointer up to ideally?
which boy? Like the second one?
Yeah,
Where we should move it?
where should we move it? Is there a way to figure out where it should move to?
Like to the last appearance of boy.
Is there any other place that we should put it besides the actual content of the word?
Besides what?
It's like where would this pointer need to go in order, because this boy needs to match, right?
Yeah.
So we can look for the next boy, and that could work. Or but then I just showed you a case where it wouldn't work.
Yeah.
Is there
Yeah.
on is there
And
under any other way we can move up the pointer?
yeah, I was saying like to the last boy we encounter. So like this boy.
The last boy that we. What if there's
Yeah, like
multiple? What if there's even another one after that? So we just find a. What if there's a boy over, like the word boy over here? We just move to the last one.
yeah, if we move it here, then but then they wouldn't match, right? Like this would return false. Yeah. And
Okay, so we had a mismatch on boy and cute. Now we need to
mhm.
match the last one, two, three, four, five elements of the top string, of the shorter string, right?
Yeah. Oh. So the last five of this thing have to match.
Yeah. So is there a way that we can move up the index in a like where would we move the index up to?
Like length minus five. So would yeah, would like go here to this boy. Okay. But then how do I know? Like you said, the five supposed to match. Oh no. Yeah, they will have to. Because once we have a mismatch, that means the phrase, like all the words will be part of the phrase. So the last have to match. Okay. So once there is a mismatch, we would see how many words are remaining in the first array and just check the last this number of words at the end of the second array.
Mm-hmm.
Yeah.
Okay. Go ahead and try to implement that quickly.
Okay. Uh, do I wrap it in like a function?
Yeah. Come up with like a function that takes in two strings and returns a boolean.
Okay. So I split them first on like a space. I have like two pointers. J. If so, if length array one equals to length of the array two, this is this case. Then I'll just return whether S1 was equal to S2. Otherwise, so I'll have to have my loop, and while I is less than length of. Yeah, I first find like the which length. Yeah, I could trade over the max of the length. No, max of length. One. if there is a match for array 1 equals array 2j, I move both. Otherwise, so here,
So while I is less than the max, could we run into a null pointer exception with this code?
uh, yeah. So it's probably better to do min. They're not equal. I still need, okay, yeah. So I'll have to check if array is equal to the last. Yeah, I need to know which one is bigger. So kind of like a Boolean is first longer. So the first is longer and I have a mismatch. I'll check if. Sure.
I'll give you one small hint to just simplify.
Yeah.
If you just look for, like, if you notice one is smaller than the other, you could swap them. You could swap the variables so that this while loop is consistent, is uniform, so you don't have to add two cases. Make
Oh,
sense?
okay. Swap them.
Or like up here, if one is longer than the other, pretend you expected the first to be shorter than the other, then the second, just
Oh,
swap
okay.
them.
So if the first one is bigger than the second one, I'll just make the first. It's like something like this.
Yeah, something like that.
So now I know that the second one is always bigger.
Yeah, just
I
to
would
simplify
check.
it.
Yeah. So I would check if array uh if array 1 starting at index I equals to the last. So it'd be like array 2 length of array 2 minus. Oh, it's messy. So this gives me how many words are remaining. And then I guess the last remaining words from array 2 will be length of array 2 minus. Just making sure this is correct. -1. Here.
Okay, sounds good. All right, we're pretty much at time. How do you think you did? How was it?
Yeah, I didn't do that good. The first question, I was trying to, I guess, think of like a efficient solution. And then I started thinking of brute force, but like I couldn't think of any good ideas.
Mm-hmm.
And for the second question, I like had an idea and then I got stuck with it. And I thought it would be correct. I should have like tried counterexamples on my own.
Yeah. Let's
Yeah,
let's walk through the first question real quick. So the first question was coming to the drawing is related to the tree question. So the way to
yeah.
solve this one is a post order traversal.
Okay.
So pretty much if you've seen an apple, you
Hmm.
should return one. The way I solve this is if you've seen an apple during your traversal, you should return one.
Okay.
So for example, this one, we do a post order traversal. So we go down this way, then we go down this way, then we go. So we hit null. So since these are null, we return zero, and they didn't see an apple, right?
Hmm.
So for four we seen an apple, so we'll return one. So one is on this side. Five we seen an apple, so we'll return one. So this one it's seen it gets two, and you pretty much just have to multiply by two because you have to go down and come back up, right?
Oh,
And then
yeah.
this one we know we seen an apple because maybe we passed up a boolean. So we just add one plus one because we're going back. So this will get three.
Okay.
And then like this will return zero here, zero because it didn't see any apples. And then you
Hmm.
go three times two equals six. So you could solve that one with a post order traversal.
Yeah.
Yeah, it's a bit
And now
tricky.
look at the solution that makes more sense.
Yeah, you should try that one. I think it seemed like you do know how to you knew the different options such as pre-order, in order, post order. But I think just practice a bit more in the post order traversals. There's a lot of questions that you could solve with a post order traversal. So
Okay.
I'll probably send you a list of good, or let me see what are some good ones.
Yeah, that would be nice.
There's some good questions, and a lot of them like by diameter of a binary tree. That's a good one for post order.
Hmm.
And just practice a bit on some post order traversals, and try this one out yourself, and I'm sure it'll help a lot. Second one, yeah, I think you understood how to use pointers, but then you were just getting confused on the solution. So you wanted to I think you had some good insights, but you just couldn't iterate to something that worked. So I think probably just
Yeah.
taking a step back, working through smaller examples, and just working through the examples and making sure that you understand and have a good solution before you implement it. Because a few times you were asking if you could implement it, but you didn't have the correct solution yet. So I think even with the first question, working through a smaller example would have helped a little bit more instead of
Okay.
working through the big question. But yeah, I think you understood the pointers, but it was just iterating to solution. You just didn't get there. So I think you have solid foundation. It's more just getting the reps in and getting more practice. But
Yeah.
yeah,
It's like so hard to think when you have to like constantly talk.
yeah,
Yeah, it's very hard. I have to practice more, definitely.
yeah. Go try that. Try this one is kind of try. Have you tried valid palindrome two? Valid palindrome two.
Uh, I don't think so.
Yeah, try valid palindrome two, and then try diameter binary tree. And yeah, you
Okay.
should schedule again soon. I think try in a couple weeks, you're gonna be a lot better. I think all the fundamentals are there. It's just iterating through solutions and coming up with something simple.
Yeah, yeah, that makes sense. Do you have any other, like maybe the way I was articulating ideas or like going
Yeah,
through
honestly,
examples?
the no comments on no nothing bad about how you articulated. I knew exactly what you were thinking. That's why I was able to
Okay.
give you suggestions. And you're going
Okay.
an approach that sort of made sense. Like I could see why you went that approach. It wasn't completely random. But then
Hmm.
those approaches would have fell flat. So it's just figuring out why they would fall flat and how you could fix that approach to make sure that the solution worked.
Okay. Yeah, that makes sense. Thank you so much.
Yeah,
I
no
think it
problem.
definitely helped me.
Yeah. Good
Yeah.
luck.
I'll def yeah, thank you.
Yeah, but book again. Let's see where you're at in a couple weeks.
Okay, yeah, for
All
sure.
right, good luck, man. See
All
ya.
right, thank you.
Bye.
Yeah, have a good one.
You too. People should start writing down their solution logic. Helps a lot with like reading it over and making sure that it works. Yeah. Agreed, agreed. Got the next person. Yo, what's up, man? How you doing?
Wait, hello? Can you hear me?
What's up? What's up? Yo, long
Yeah,
time. How you
yeah, long time.
been?
Uh, how is Workman? Wait, you switched over to a different company, right?
Yeah. So when were we training you up? That was probably like 9, 10 months back. We did 3 different sessions, right?
Yeah, like three to four. That was like February, March, I think.
Holy. Yeah. So I was working at Rippling, but now I switched over to working at Meta. What about
Do
you?
you like it more than Meta?
Do I like it more at Meta?
Yeah.
It's I mean, yeah, I like Meta more because I have more time to think about my solutions or the code that I'm gonna pump out.
I
Rippling
heard
is
there's
kind
like a
of
lot
go
of
go
like,
go.
oh wait, sorry.
Rippling is it's pretty fast paced and they really don't. I feel like they don't care that much about the code quality. Depends on the team, but it's fast paced and you have there's so many things due all the time, so you don't really get the chance to actually like think of a
Yeah,
good solution. Honestly, you kind of have to write up the first or second thing you think about.
I heard like big tech has like a lot of like red tape. Like if you want something done, like you have to like ask your manager, and then your manager has to like ask your manager's manager.
Honestly, it's not like that. Meta
Really?
Meta is known to be super fast paced and have no bureaucracy. And honestly, I'm pumping out code the same just as easy as I was at a startup and as just as much as I was at Rippling. So I think it's been
Oh,
pretty good so far. I'm able to pump out code. I'm able to come up with my own designs and figure out what I need to work on.
are you like a senior?
At Meta, nah, got downgraded, bro.
Oh shit.
It's all good. The pay is still more, so I don't really
Oh, that's
care.
not.
I just care about the money.
Yeah,
If they call me if a company calls you senior and they don't pay you, like who cares about your title?
that's true. That's
Mm.
true.
Like I'll go back to junior if it's gonna pay me more money.
Yeah, that makes sense.
So yeah, what about you, man? You're working at or you did a Jane Street. You did a Jane Street
Fellowship, yeah.
fellowship, right? What was that all about? How was that? How did that go?
It was really fun. It wasn't the length of like a usual internship. I think a usual internship is like 12 or 10 weeks.
Yeah.
Ours was like 8 weeks. It's really close group. It was like a small group. I think like the intern group is like 100 people. I think our group was like it's 12, so it was like a really tight group. Like
Wow.
it was like sort of like a friend group. It was we all just got close to each other. It's like the apartment was building they gave us was like really nice. That was like the best part. Half my day was high key like eating, and they have like breakfast and lunch. That was amazing.
And they got
Um,
free food there too at Jane
yeah,
Street?
yeah,
Dude, that's
breakfast.
crazy.
Yeah,
So
yeah, breakfast, lunch. It was like an all you can eat buffet, bro. It was amazing. Oh my god.
nice. Was it the same breakfast every day or they switched it up?
No, that's the thing. They switch it up like every day of the week. And
Damn.
same thing with lunch. And like some days with lunch, like actually I don't know how much I can say.
Yeah.
Like sometimes the lunch is like it's like different themes. I don't think I can like say much more than that.
Yeah.
But
I
yeah,
mean all the Bay Area companies have food too, so I know what it's like to
Yeah, I
buffet, and
think
then there's
Roblox
multiple.
has better food.
Where?
Roblox.
Oh yeah, I heard a lot of most Bay Area companies offer food because they have to in order to compete. So are you
Wait,
allowed? Or go ahead.
I just know that Amazon has no food. Like my friend, he was working there this summer, and then he sent me a picture of like a banana basket.
Oh my
That's
god,
all they
yeah.
could.
I think they get free coffee, but they get like one coffee, and yeah, no free food. But
It's treat them
honestly, if
like
I ran a company, I would make sure I would make sure people get free food because it makes people more efficient because they don't have to worry about cooking. But
I think more than that, it's like if you get lunch in the office, and you're more inclined to sit with the people on your team. So it's like you talk about work even when like you're not working, like during lunch.
yeah, and it saves so much time. You don't want somebody wasting 1 to 2 hours leaving every day to make food.
Yeah.
Yeah. So are you allowed to talk about what technologies you were working on or what you learned over the summer working at Jane Street?
Yeah, I mean, what I learned was like I think I probably yeah, for sure. I think what I learned was like obviously like the language they use, like OCaml. It's
Yeah.
pretty nice. I'd
Functional?
probably like never use it, yeah, function like a lot of like FP. I'll probably
Mm.
never use it outside of like an FP class I might take in my school. But I think it's like it like makes you a better programmer, probably. Like it teaches you like think in a different paradigm. I don't think it's like it just like really opens up to like the way you think. Like you probably shouldn't be like you probably should like have like a lot of immutability in your functions. You shouldn't like be side affecting a lot. Like I think the program in general just like taught you a lot about how to write better software. And I think it's stuff that like no amount of like lead coding can really teach you, and also like no amount of like personal projects, I guess. Because when you make personal projects, it's like you're not really policing yourself on like the level of quality that you have,
Yeah.
because like your goal is to like get it out as fast as possible and like generate like I don't know like revenue or whatever if it's like
Mm.
a startup. But you're never really gonna have like somebody that's like policing the quality of it as you might have like in an internship, or like I think especially for mine, it was like the express purpose was to like help you level up.
So they're really code reviewing hard, not letting you push code unless it's really, really high quality.
Yeah, yeah, yeah. I think the language they have, like OCaml, was like really conducive to that too. Like, um, I think OCaml was like it's a lot easier. Like OCaml was like a language that's designed to like help you write code if you know what you want to do.
Yeah.
But if you don't know what you want to do, then like and you're like writing software like iteratively, then it becomes like really, really hard.
Yeah.
So it encourages you a lot to like think about what you're building before you actually do it, which I think is like pretty helpful.
So
Because like
so
you,
why do they
yeah,
use OCaml? Is it just for speed? Is it because it's just cleaner code when it's functional and you follow all the functional principles? Like, what's the main reason?
I think they have. Well, they gave us a talk on why they use it. I think they have
Yeah.
like the same talk online. Like you probably like put up like why Jane Street uses OCaml.
Mm.
Um, yeah, it's like I honestly forgot actually, but I forgot like the first reason why they use it. But I think they just kept on using it, and then like there was no reason like switch from it,
Mm.
because it's not like people are like that upset about using it. I think the thing like people like don't like it at first, and then like they grow to like love it. But
Yeah.
I think uh the thing with OCaml is like because it's an ecosystem that a lot of people don't use.
Mm.
It's like all supported by Jane Street, and so I think the reason they've invested so much into it is because like they're like the only ones that use it.
Yeah.
It's like it's a bit hard, like especially like with documentation. Like the only documentation for like certain libraries is the ones that employees themselves have written, and sometimes that's just like terrible.
Mm.
So there's like a lot of pains with that, but I think um, overall it's like worked for them.
Yeah. So what's this fellowship program like?
We basically like made like I think it's a bit more akin to like a boot camp that
Mm.
you'd probably think of. It's like we sort of had like a new project around every week. Not all of them were like finance related. Some of them were like there was like an electronic trading. There was like an electronic trading competition. That was pretty fun. Um, it was like yeah, like every week there was like a different project. Where we like use OCaml or like learn like use a certain technology. And like get that reviewed. And I think the projects themselves probably were like not as important as the feedback that we got when we were like writing them. Like it's sort of like the little things.
Yeah.
I don't really know how to like verbalize it, but it's just like really, really like little things like that add up to like making a very maintainable software. I think the best way I can put it is like they encourage you to write your code in a way that it's like an open loop. So like if it's like a close, like what I mean by that is like if it's like a closed loop, then when it comes time to like make another change to it, then like it's really, really hard for you to augment the functionality. Like you have to like rewrite large parts of the existing code in order to like add new functionality. So what they really value is like making the code like open. So that way, like when you come to the future or like another programmer like wants to make a change to it, it's very obvious where they would make the change and where they could like use existing functionality to like create the new one. Um, yeah, it's like it's like
like
hard.
open
Yeah,
close principle, like open for
sorry.
extension, close. Like, is it like the open close principle, open to extension, close for modification type thing?
Oh, I've
Ever
never
heard
heard
of
of that,
that? Okay.
but probably something like that.
So
It's kind of hard to get
or go ahead.
specific examples off the top of my head, but that's pretty much.
So it's pretty much so you just learned a ton of design patterns and stuff. That's the main that was what a
I
lot
think
of the
yeah,
stuff you learned.
that's like the biggest part. Like systems designing is probably like system designing. That's like the number one takeaway from the program.
Yeah. So it's
And
pretty much every single week you have a new project. Does this project ever go out into production, or it's more just a project just to help you learn something and they already kind of know the answer? That way they can review your code and then make sure that that code is good.
the latter, but I don't think that it's ever like an answer. All the projects had like pretty good creative freedom, and they're all like reviewed by full timers.
Yeah.
Yeah, there wasn't like a correct answer to any of them. It was more so just like it was like an extended interview question almost.
Hmm.
But it's like spread out across like 8 hours a day and like 40 hours across the entire week. Um, and I think the progress was like pretty tangible. Like from the first week to like the eighth week, like it was pretty obvious how like we'd all have like grown in our skills.
Yeah.
But
How
I
were
think
the or go ahead?
sort of what it's not like a lot of there was this one time like we actually no I don't think I can say that, but yeah I don't think much of our code went into production. No.
Yeah. How were the other students? Were they cracked?
Yeah, they were definitely correct.
It's crazy. So what's next for you then?
IK this recruiting season has not been looking too good, but I think the only thing I have is I have a interview lined up for Bloomberg,
Nice.
but that's pretty much it. And I also have a Citadel launch interview, the second year one.
So what year are you in? You were a freshman last year, right? Or no?
Yeah, I'm a second year right now.
Oh wow, you're second year. So you have a Bloomberg already? So
Yeah,
you have
not the offer, the interview.
yeah. Okay. So has the Jane Street interview been helping you land more interviews now that you already got your foot in the door?
Um, no, wait, not yet, because I think Bloomberg and Citadel are like the only ones. Like the ones that I guess take sophomores, like known to take
Oh,
sophomores.
you got a Citadel one too? Is it just OA or like full out interview?
I got the interview after the OA.
Oh
I did the OA.
wow. Nice. That's crazy. What do you mean it's not looking good for you? If you have a
Yeah,
Citadel
no, but
interview?
like it's like compared to like the other applications that I've put out there, like it's not
Yeah.
proportional.
Who have you applied to? Have you applied to all the fan companies and stuff, or you don't really care for that?
But what do you mean I don't care for that? Like
Or I'm
I
just
don't think I'm
wondering.
no, I applied to all of them. Like I applied to Google. Google hates me. I
Yeah.
applied to wait, did I apply? I don't think I even applied to Microsoft actually. I think I completely forgot about them. Um I applied to Meta. For the Meta one is so weird. I don't think they even got my application. Because I looked at my careers profile like 2 days after
Mm,
and I swear like my app isn't even there.
interesting. Yeah, I don't know. Maybe submit it again. What about all the unicorn companies?
Yeah, I applied to Stripe. I applied to Ramp. Uh, I was also gonna apply to Rippling.
You getting hit back
But
from those?
uh, I didn't hear back from Stripe. Ramp, bro, I fumbled the Ramp away so bad, and then they rejected me.
No way.
That was like my first away of the season.
Yeah.
I thought I was like way too arrogant. I thought I could do it like
Yeah.
without like any like, up or anything.
Aren't they more just practical too? Those ramp ones?
Yeah, the ramp one was like I have like zero excuse. Like it wasn't even like leak code. It was just like
Straight
it was
coding,
like
right?
just like straight coding. It was like forgiven.
Yeah, everyone's saying ramp one is oop.
Yeah, I just like fumbled. I did like I don't think like it was like there was like a break between like when my thing ended and like when school started. Like I
Yeah.
did like no coding in between, so I just like straight up did it and
Yeah.
then fumbled.
So what courses are you taking this year? It's your second year now, right?
Yeah, I'm taking CSO or sorry, I'm taking I'm taking only two CS classes right now. I'm taking Comp Arc. It's probably like what they'd call it at other schools. Uh, and then taking like algorithm proofs. I don't know what you would call it like other schools basically like a math based proofs class on like different algorithms.
Yeah, it's like prove the correctness of this algorithm.
Yeah, exactly. Yeah.
That's the second year course there?
Yeah. Most people take in their second year.
So how many courses are you taking? Is it 5 courses per semester?
Yeah. Right now I'm taking five. I'm taking three other classes, but they're not related to CS. They're just like part of my core requirement.
Oh, okay. Is that how it works? You only take a couple or 1 or 2 CS classes per semester, and there's a bunch of random courses that you have to take?
Well, I think my last two semesters, like my first year, I sort of like front loaded on a lot of my CS classes. So
Yeah.
it's like right now I'm taking like less per semester.
So what did you take? What CS courses have you already taken?
I took discrete, DSA, OOP,
Mm-hmm.
um, linear algebra, but that's not a CS class, but
Sure.
like a math class. Um, that's pretty much it.
Okay, when can you take computer networks?
Uh, I think I'm gonna take that next semester along with operating systems.
Nice. What about any ML courses?
I don't know. I might take like a ML elective, but I'm not too sure.
Yeah, I mean, you should definitely look into those courses. That's the future. I would definitely make sure I take those courses. Like understand all the things related to ML or AI.
Yeah. I mean, a lot of the like the juicy classes, they're like the grad classes. I think I need to like get permission for them.
Like the grad like the third course or what do you mean? You said grind classes or grad classes?
No, like grad, like for some
Okay, I
like the
see.
ML classes, like the ones that like actually teach like a lot of like useful things.
Yeah,
I'll get like express permission from like the department in order to take like the grad level classes that are actually useful.
I see. Yeah, somebody in the chat said computer networks is the most useful CS course ever. I agree. This is my favorite course. What about distributed systems or distributed algorithms or databases? When are you taking that?
I think I'm gonna take that maybe next semester or maybe like junior first semester. Definitely,
Nice.
I definitely want to take database and I definitely want to take networking.
Yeah.
And also another one is like I forgot the name of it, but it's basically like all about like Unix and like the Linux kernel. I want to take that
Operating
too.
systems?
No.
Even deeper?
It's yeah. No, not deeper, but just like more practical knowledge of like how the Linux kernel works.
I see. Damn. So, are you trying to focus more on sort of like low level C++ and work in the quant field or work in the like hedge fund field, or do you want to work in like tech?
I think my dream thing is probably like working at a unicorn, honestly. Like I think wait, like you said, like wait, if unicorns have like free food, that's like the one thing I was like, if unicorns don't have like free food, then I might not go.
Yeah.
But it's like I just like the vibe of like unicorn. Like, well, I've never worked at one, obviously, but like I think it would be like really, really fun. It's like a big group project. It's like everybody feels like really personally involved
Yeah.
in like success of the company. I think that's fire. Like I would definitely like want to be a part of that. I think if they have free food, like that makes the deal even better.
Yeah. I mean, dude, like in the Bay Area, every company has free food.
Wow.
Like if you go to OpenAI, they have free food. Anthropic, free food. I mean, those are like massive unicorns, but I mean, Rippling was had free food even when they're like just barely over unicorn. Now they're way over unicorn. But I don't know. Yeah,
Wait,
there's pretty much
Rippling isn't a unicorn anymore. Wait, it's like
Well,
past
it's way,
unicorn.
way past. Or unicorn is 1 billion, so it's still a unicorn, obviously, but it's worth like 15 billion. So it's pretty massive
Wait,
company.
and is Stripe still a unicorn?
Well, like all of them are basically unicorn is any company over 1 billion. So they're all technically unicorns, but their Stripe is worth probably 60 billion right now. They're huge. That's honestly working at a ramp is worth 15 billion. Unicorns, a unicorn I would say is like Cursor, which is valued. Cursor a year ago was valued at like 3 billion.
I see.
So once you're over 10 billion, you're almost like a large corporation at that point.
I get what you mean.
So I mean, things change as you get more funding and as you get more revenue. So Rippling is a massive, massive company now. Probably has 4,000, 5,000 employees. It has more revenue and people than a public company. So it's essentially like a public company. And yeah, Stripe is basically just like a big tech company right now and did an IPO.
No, I see.
But for example, Ramp is huge now. I'm sure it's not the same startup experience as it was before. Like probably you probably get still move fast, but it's massive, massive company right now. I mean, there's so much options for you. You can work at Fang. You can work at like a big private company like Stripe, Rippling, SpaceX. Those are massive private companies. You could work at companies that just crossed unicorn, like hyper-scaling companies. You can work at early stage companies just trying to find product market fit. You could go work at a hedge fund. The ones that I like the most, that I found the most exciting, are the ones that are in hyperscale mode. The ones that are growing their revenue really, really fast. They're like doubling, tripling, quadrupling their revenues year over year. So imagine
Like,
you joined a company when they're in their hyperscale mode. So like OpenAI in 2023, from 2023 to now, that company was in hyperscale mode. Imagine how much stuff you would learn there, and how that stock has ballooned or went to the moon in those 2 to 3 years. I think that's the sweet spot. It's hard to find though.
yeah. Wait, Haki, I think before, like I thought Fang was like the upper echelon, but now I'm realizing there's like levels to this. Like
Yeah, there's a lot. Like what do you mean?
like there's like Fang, but there's like hedge funds, there's like quant shops, there's unicorns, there's like startups. Like they're not like all like it's not like one is better than the other, like strictly. Like some are better for like different people. Like I don't think everybody wants to work in a startup or everybody like wants to work like a quant shop, for example.
Yeah,
But it's definitely like when you like before, like when I used to think of like software engineering, I used to like only think of big tech.
yeah,
But I think like now it's like a lot more broader than I thought.
yeah. So like from your experience right now, do you think an intern at OpenAI would learn more than somebody
But
work? Do you think an intern working at OpenAI would learn more useful things or just learn more in general than intern at Jane Street?
well, I can't really speak on like what I don't know. Like I don't know what the interns at OpenAI do. I think I don't know. I think James is like really unique in that they really are very supportive. I guess like is the best way to put it.
Yeah,
They have like a ton of intern specific events, a ton of workshops for people like just like want to level up. I don't I think the level of commitment actually like that Jane Street has to like not only its interns but like also like even just like full timers and like making their career like balloon. I don't
yeah,
think it's very notable, and I don't think I would be surprised if like a lot of other companies match that. To be honest, like I
yeah,
don't think OpenAI matches that, but I don't know much about them.
yeah. The only thing I worry about working at like a quant firm or a hedge fund is just being hyper focused on one thing, which is the markets or building code for the markets.
I think
versus,
you'd be
or go
I
ahead.
think you'd be surprised. I don't think a lot of engineers think about the markets all that much. I think they're just like focused on like how their specific work contributes to the market. Like like it's not like that they I think for being a trader, obviously, like you have to know like a lot, like a bit more about the markets and like how they function. But I
Yeah.
think as like a developer, I don't think you need as much knowledge of the markets. I think you just like focus on like how does my team's work contribute to this specific part of the market.
Yeah. But how the part that I'm worried about is how applicable is the work that you would do? Like how would it transfer over if I pretend I wanted to start my own startup, or I wanted to get into AI, or I wanted to go into a different field outside of hedge or outside of like Wall Street. I know there's a lot of founders that like have switched over in the past too, but how applicable is the stuff you learned to like the general software engineering field? Did you find it pretty applicable?
Wait, yeah, I think that's like the whole thing about it. It's like very, very uh well, the one that my program was especially applicable, but I think for interns it might be a bit hard because it's like you can't as easily like publicize the work that you've done, especially if it's like under NDA. And
Hmm.
it's also like the language and like the libraries I use at the company are going to be so specific to the company that no company is going to think that those skills are in demand, if that makes sense. Like nobody's
Yeah.
going to like want to hire you because of OCaml, or nobody's like going to want to hire you because of like a library they use in OCaml.
Hmm.
Like not transferable in that sense.
Yeah.
But I think overall, like the skills, like the art of programming, I guess, is a transferable part, and that's
Yeah.
like less art to verbalize in a resume.
Yeah, it makes sense. I think the name speaks for itself. Once you have once you have Jane Street on your resume, you probably get a lot of interviews. And I mean, yeah, I agree. It doesn't really matter what you work on as long as you're working on hard things every day, and as long as they're programming related, you're just strengthening that programming or problem solving muscle. You could probably wherever you go, you'll succeed as long as as long as you push yourself each day to improve and work on things that are harder than what you're capable of.
That's what I realized too. I think like I don't think the like like resumes have like a library skills like or like a tool skills and like a list like I don't know like React or Express
Yeah.
or like Node.js or something. I think after that program, I feel like a little bit conflicted about that because I think the goal shouldn't like those frameworks and stuff. I feel like they're a lot more easily teachable than just like raw problem solving skills.
Yeah.
I think, um, yeah, like
Yeah.
I think I think at a certain level, it's like less about the libraries that you use, or like the language that you use, and more so about like it's like a lot harder to like measure, but like how good are you at like problem solving?
Yeah. No, I agree. That's why when I'm looking at people's resumes, especially when they're more experienced, I barely care about what programming language they're using. A lot of people they care to talk about what programming language they use, but I don't care about that. All I care about is I want their bullet points to show me what business metrics they moved, what business impact that they had, what behaviors that they show. I don't really care about what language they did in order to move that business impact. Say they optimize some query, right? I don't care if it's SQL or no SQL. As long as they know how to optimize a query, I think that's useful for wherever job you're going to be. If you built a full backend API and made it or make it public facing, I don't care what language it's going to be because I know that if you had to do that in Python, you had to do that in Express or JavaScript, you had to do that in Java, whatever. You still know the same concepts, and a lot of that stuff just transfers over. Just the syntax is just slightly different.
Yeah.
But yeah, like what Alpha is saying too, bigger companies definitely don't care, but smaller companies do care. That is true, Alpha.
That's not what he said. He said entry level, like for entry level positions, it's more important.
Yeah, exactly. It's super important. Honestly, when we were we'd when I was at a startup and we'd hire a lot of people, especially we'd hire people who did a lot of great things in Java. They would come in and they would not be able to pick up what we were doing that as fast as somebody who's already working with the technologies we were already using. So
Wait,
it does
I
make
keep
a
thinking like
difference.
I think there are like some exceptions though. Like I think like Rust, like I've worked a little bit in Rust, and I feel like if I'm like hiring for like a Rust role or like in a team that like primarily uses Rust, like I don't know, I just feel like if it's like a Rust team, I don't think you like it's not reasonable to like expect somebody to like learn Rust and like be functional at it within like an internship time frame. It's like you just need like a whole month or like a whole like maybe like 2 weeks of that internship period to just like learn it. Like because I think for some programming languages it's less about like the syntax and more about the model. I think like OCaml is one of them because of like functional programming,
Yeah,
but I think Rust is probably like a big one too because of the borrowing like paradigm.
yeah, that makes sense. So when is your interviews?
Bloomberg is on Friday, and then Citadel is next week. I actually forgot.
Damn. Do you know what kind of questions that they're gonna ask you at Citadel? Like what you need
Um,
to prepare for? Like are you gonna prepare C++, lead code, designing a
no,
heap from scratch, creating a
my
game?
well, yeah, I feel like no, I don't know because I just got the offer like yesterday, or not like the offer, like the interview invite yesterday.
Yeah. Well, good luck. Let me know. Do you want to do a mock interview at some point to prepare for Bloomberg, or
What if we did like a calm lead code like right now?
right now? Let's see.
Yeah, because I think I like started my practice. Well, I was like practicing like from last week, but I think I like really started after the
Okay,
invite.
when did you tune into the chat, or when did you tune into the stream?
Like at 9:58 Eastern because I realized like I booked a
Yeah.
thing.
Okay, you just tuned in right before you had to come in, right? So you didn't see the
Yeah,
last question? Okay.
I saw like the graph thing they made, but I
Oh
forgot
shit.
everything.
Okay,
No,
okay.
like a
I
sketch,
got a
but I had no.
different question. I got a different question. Okay, I'm gonna send you this. All right, yeah, we can do a calm leak code real quick.
Did you see
All
me?
right. Yeah, yeah, yeah. Okay, I'm gonna do intro. Hey everyone. So today we have a Jane Street intern hopping onto the stream. He
Bro,
has
wait. Pause.
what?
I don't think you can say intern. I think that's like not allowed.
What do you mean?
Wait, matter of fact, don't mention intern at all. But
I'll
matter of
just say
fact, don't
worked
mention.
at Jane Street.
I feel like no. I feel like that's also like disingenuous because like I don't know. I just don't feel comfortable saying
Or I'll
that.
just say you did a Jane Street fellowship.
I guess, but like you know what?
Bro,
Never mind.
you gotta market yourself, man. Okay, I'm running it back. I'll run it back. And
Wait.
then
Okay.
and I'll ask you the
Just
question.
say. Just say. Wait. Just make it like vague. Just say like you had like somebody that spent their summer at Jane Street or
Yeah, yeah,
whatever.
yeah. Okay. Yeah, chat's saying you're trying to be humble. Okay, I'm gonna start. Hey everyone. So
I'm
today,
just trying to. Oh shit, my
oh, go
fault.
ahead.
I'm
All right.
just trying not
No,
to
good.
lie.
Okay, let me run the intro.
Okay.
Hey everyone. So today we have somebody who spent their summer at Jane Street, and hold on. Let me run it back. Hey everyone. So today we have someone who spent their summer at Jane Street, and they were first year. Now they're only in their second year, but now they have interviews coming up at Bloomberg and Citadel. So we're just gonna quickly test his lead code skills. I'm gonna ask him a question. Let's see where he gets to in 20 minutes. All right. Okay, I'm gonna drop in the first question. It's been a while since we did one of these. I have videos where I was helping him when I was training him up for his interviews. I think he had one at 2 Sigma, and we went through 3 different sessions from simple BFS, DFS arrays all the way up to dynamic programming. But let's get into this first question. So I just posted in here. Go ahead and work through it.
Okay.
Or let me mention it at a high level. You're gonna be given a list of points in a XY, like a Cartesian plane. So a list of points xi and yi. We need to return the minimum area of a rectangle. We need to see what rectangle produces the minimum area given the points that I give you. Does that make sense?
Yeah.
So we need
So
to
it's
find
like
4 points that make up the smallest rectangle area.
I see.
So I'll let you go ahead.
So okay, so
We
you have
got 20
four.
minutes.
Okay. It's kind of hard to visualize because of like well, it's like
There's a drawing feature.
oh there is, yeah. Okay, so let's say like my points are like I'll just like make like a bunch of random points for for visualization. Okay, so and then I'm supposed to find 4 points. All right, that's not actually no. The question doesn't even say that. The question says find the minimum area of
The
that is made
rectangle, yeah.
from 4 points.
Exactly.
So, let's see, one such thing could be. Well, I think okay. So I think a solution would be to uh, get every possible like set of parallel lines. So like it's not possible. Like just given 4 points, it's not possible to like form a rectangle if it's just 4 points, right? Like it'll just be like a parallelogram or something. So I think the first step is like find every possible rectangle in the
Yeah.
brute force. So that'd be something like, well, the way I drew this is kind of weird. I think
Like
you'd have to like find every, like given a line, given every possible line you can make from like one point to like the other,
mhm.
uh, see which other pair of point is like parallel to that. So like let's say this was one, and then like a rectangle could be formed from this. It's probably like definitely like a better way to do it though, because like just finding every set of lines is like n squared. It's like every point like the other point. And then finding like another parallel point is like another O of n squared. So I
Yeah.
think that's the approach. Let me see.
Wait, one part of the question is the points or the sides should be parallel to the x and y axes.
Uh,
So
the
we can't have a sideways
oh
rectangle like this.
oh wait, yeah. Oh, that's obvious. Yeah. Wait, no, it's not obvious. Wait, yeah, I think that simplifies it a little bit. So wait, so the parallel lines are only allowed to be like flat. So this like that.
Essentially,
Like you're not I see you're not allowed to like have like diagonal lines. Okay.
you can't have a diagonal triangle.
Not a triangle, but like this
Or
is what
sorry,
like a rectangle.
yeah, diagonal triangle. Or sorry, diagonal rectangle.
Yeah. Okay. I'm just make sure I'm reading the question carefully.
Yeah, go ahead, read it again.
Turn the minimum area of a rectangle formed from these points with sides parallel to x and y axes. There is not any such rectangle. Return 0. Okay, let me think about like why the output is 4 here. It's because 1 1 1 3 3 1 3 3. Yeah, so the rectangle formed from 1 1 to 1 3. That is 3 long. Wait, 1 1. Yeah. And 3 1 3 3. Okay, yeah, those are parallel lines. Okay. So like given a point here, in order to like find every possible rectangle, I want to see like in order to like form a rectangle then with the constraints they give us, we need at least 2 points on the same x plane, and 2 points on the same y plane. So, and those same, let's see. Trying to think of a quick brute force, maybe. Maybe for each point. So like let's say like for like 1, 1, for example. I'm just like make a new graph here. So they give us 1, 1, 1, 3, 3, 1, and 3, 3, and 2, 2, like somewhere in the middle here, which is irrelevant. Yeah. So let's like we think like so we'd go to the point 1, 1, and then we think, okay, like what are the other points here that like form a parallel line? Those would be 3, 3. Like we looked for the rest of the array and we see like 3, 3. Not 3, 3. 3, 1 gives us a parallel line, and 1, 3 gives us a parallel line. So, and then from that, can you say anything else about that? Actually, what if we went like x-axis by x-axis? It's like we look at x equals 1, or sorry, y equals 1. And then we see like, are there points here that like form a horizontal line? And like we go again for like x equals 2. Are there at least 2 points that form a horizontal line? And then keep going. But then like that's like terrible for efficiency because like you might like explore some x-axis that don't even like have points at your input, and also like the boundaries for it aren't well defined. Like for all we know, there could be like points in the negative right here.
Yep.
Okay, so like yeah, going through each x level probably, or sorry, y level probably wouldn't be a good solution. Let's see. I think the parallel part is interesting to me. Size axis does not intersect rectangle return 0. I think I'm getting a bit too overwhelmed with like the minimum area rectangle. Like, how would I find a rectangle? Like, given like a bunch of arbitrary points, how would I find the rectangles that exist on the plane?
Yep.
Let's see. So 1, 1, 1, 3, 3, 1, 3, 3, 2, 2. Has it been 20 minutes already?
No, you're still good. Been 9 minutes.
Oh.
What are you thinking? So I think that's a good insight. You said
think-
how do I even find out if a rectangle is in there, or
I
how do
think
even
before,
go ahead.
yeah, I think before when I said something like when they give us like 1, 1, 1, 3, right? I said like if we have like this, if we know like we have like a parallel point here and like a parallel point here, it's like the thing I was stuck on is like how do we like get the relationship for like this point here? Because this is not on the same plane. There's like I don't know what you call it, like not perpendicular, that's like the wrong word. Like maybe like part of the problem could also be like finding like triangles instead of like the full rectangle. So like finding a set of 3 points and then see if like this 4th point over here exists. Like find the triangles.
Here.
So it's like given 3 points, then like the next step is like, does a fourth, because like if we have like this set of points right here, then like we know to like we know the coordinate of this point over here. Like we know the coordinates checked for it in the array. It's like if that point exists, and this is a triangle, this is a rectangle. Does that make sense?
Yep.
So
So you're trying to calculate. You want to be able to calculate the fourth point once you figure out 3 points.
yeah, like given 3 points, let me see if the fourth point exists in the array.
And then what happens if it does?
If it does, that's like one such triangle. That's like one such rectangle that we can like consider, and then we like compute the array of that, or sorry, compute the area of that, and then I'm thinking we could do like not two passes of the array, but like 2 like conceptual passes of the problem. So like one step would be form every rectangle. So a really naive thing to do. I think I sort of have like a before solution. So like given our points array, right? We sort of find every combination of 3. So like we take like 1 1 1 3 3 1, and then here like we calculate like, what's the logical fourth point? It's 3 3. So we'd like look in the array and we'd see 3 3. And then if it exists, then we add it to like another rectangles array or something. And we like add the area of that rectangle to like the rectangles array. Or not even actually, we just have like a running maximum or something. And then like we'd move on with like another rectangle. So I think one other rectangle here was like let me see, like 1 1 1 3 3 1 3 3 and 2 2.
Yep.
Oh, so I guess one triangle that we could form was like this is like one such triangle, right? And then we look, or this is not, no, actually I want to like clarify my definition. I only want right triangles because there's the only ones
Right
like make a right.
triangle. Okay.
Yeah. So like we'd expect like a point to be here, and so we like calculate that position, but then we wouldn't find it within the points array. So that's like not a rectangle, and so like so on and like we try like every combination of 3 points within this points array, and if we find like a valid rectangle by forming a triangle, then we calculate the area, and then keep track of the maximum. Does that make sense?
Okay, so like a triple for loop type thing, like these 3 points, check if the fourth point exists.
Yeah.
Yeah, I mean, it sounds like it would work.
Yeah, but I think the heavy lifting there is like finding every pair of 3 points. I think that's like a lot of work to do.
Is there a way to calculate the points with knowing less than 3?
I mean, I guess if you have like 2 points, like 2 opposite like vertices, it's like top left or like bottom right, like bottom left or like top right, then you know, oh yeah, I guess like you've like constrained the problem, then like then you know like the position of the other 2 points. But like that still narrows it down from like 3 points in your rate to like 2 points. It's like what can we do with that information? Then it's like within the points array, like for every point, you would within the points array, you go to the rest of the array, and like for every point, you would compute the 2 remaining points. So like if you got like the bottom left and the top right, then we look at top left and bottom right. Like we compute those and we see if those 2 exist in the array, points array, and then if they do, like we compute the area and then we add it, like we keep track of like a maximum. I think that solution probably works. I think the complexity of that would be, it's like first you, like for every point, you go through every other point and then find 2 pairs, and then you also like look through the array again to see if those remaining 2 points exist. I think that would be like O of n squared. Wait, so it's be like an outer loop, and then within the inner loop, you're doing like n work within the inner loop to search for the remaining two vertices, which I think would be like n cubed work.
Is there a
So I'm
faster
not
way to find the other point if the other points exist?
sorry.
Is there a faster way to find how if the other points exist?
Um, given the array as it is, I don't think so. Probably like something we can do with
So
the
you're
input
saying
though.
once we find 2 points, we're gonna search for point three and point four, but the way we're gonna search for point three and point four is by looping through the array looking for those points.
Yeah, that's like the most naive thing I can think of right now.
Like, what's the fastest way to look things up? Just
Yeah,
faster than Oven.
I mean the fastest way to like looking this up is with the hash table, but I'm not sure what the. Oh wait, no, we don't need. Yeah, we just care if it's like there, like a lookup check. I think a hash set would probably like be fine then. Like we
Hmm.
just want to check if like the point exists, and not necessarily like want to like modify like act the same thing with it. So I think wait, yeah, I think you just like have to like convert the points to a set, um, and then for every point, it's like for every given point within our set, we loop through the rest of the points set, um, and then compute the remaining 2 points, see if they're in the set, and if they are, compute the area of the rectangle formed by those 4 points altogether, and I keep track of like a running maximum. Does that make sense?
Yeah, go ahead and implement because we're already at 17 minutes.
Oh shit.
Go quick, go
Oops.
quick.
So we have our points. So I think Python tests are iterable, so this should probably work. So for point and points, so for and now you want to compute running points. So you have like top left, bottom right. Um, definitely is like a clever formula for this with like min and max. It's like you don't really care if it's like bottom right, like top right. Um, that's like brute force. It's like if
What if it's not less than?
then it wouldn't be top left. I
What do
think
we want to do then?
there's definitely like a clever formula for this. Wait, are we given tuples or are we given arrays?
This is the input we're given.
So it's arrays, right?
Yeah.
Like not tuples.
Mm.
Uh, oh wait, I don't think this first step would even work then, because like only tuples are hashable, because like lists are immutable. Like assuming that works though, then oh no, I think you can do something like set.
Yo, congrats on your Roblox interviews. Do you have any advice for Roblox? I don't know. I've never done one before, but congrats because I know they
That'll
asked
work.
you like the hardest questions in the OA. So just
For
passing is
point
wild.
and points,
Just do tagged
tag
questions.
point and points. But I sort of know what I have to do, but it's just like a lot of. There definitely is a clever way to do it. The way I'm thinking right now is like I just like check if this point's x coordinate is less than that one, then it's like the top left, and I want to find the bottom left point, and I want to find the top right point. Like I'm basically like going through like each possible case where okay, do we have top left, bottom right? Do we have bottom left, top right? Do we have oh wait, those are the only two ones. Oh, and like vice versa, because one could be less than the other. Actually, I think we could I make sure like the first point is the one that comes before. Okay, now I've like sort of normalized it. Okay, so now is it top left, bottom right, or bottom left, top right? So like this one. And I want to compute bottom left is equal to the left 0 with the right y.
So what are these different cases?
So so before this, like we've normalized it to where this left point is always gonna like appear to like the left of the right point. And so once we're sure of that, then I have like two cases. One is our 2 points are such that like the left one is on the top left and the right one is on the bottom right. And the other one is going to be like if left one or like just like else pretty much, then it's going to be bottom left, top right. Because that like affects how we compute the other vertices.
Yeah.
Does that make sense? Yeah. Top right. Bottom left, top right. Top right, right. Yeah, right's x-axis, and then
Okay, let's say in your for loop it says for left in points, for right in points.
yeah.
Could we just skip if left, or should like we only execute the code if we actually have the top left and the bottom right?
I guess yeah. If like yeah, because it's like n squared. Yeah, you're right. So we would like do that. That'll work too. And then if left 0, if left is plus 1, So once we have that, we just check if bottom left and no wait, that's not how that works. If bottom left in points and top right in points, then let's add a result here. Area is equal to max the current area.
We're trying to minimize the array.
Sorry?
We want to return the minimum area.
Oh yeah. Min area and area formula is just top right 0 length times width is like
Okay, I think I have another person coming up, so this is a good stopping point. How do you think you did? How was that?
thought it was pretty terrible. I mean, I think I was a bit stuck. I think I was like complicating a lot at the start. Like I was like thinking there was like a very math heavy way of doing it. Like there was like something that I wasn't looking at, and so I was like focusing on like some property of the problem that I could like exploit. Like, have you ever seen like those weird like math LeetCode problems?
Mm-hmm.
I think this one ended up being like a lot simpler than I thought, and like the solution was like really right in front of me the whole time.
Yeah.
Yeah, this was like a lot. This is like a pretty easy problem. I can't lie. I just like kind of fumbled it.
Yeah. I think the main thing is you're just working through this massive example. Like if you look in the drawing, you just have all these different points and you're trying to figure out the triangle or squares in there or rectangles in there, then you're working with triangles. I think just work through a very small example at first. Instead of going through a large example with no clear answer, work through the small example that I gave you that has a clear answer. And then I think you would have got to the brute force a lot faster, which was just figure out all the rectangles and
Yeah,
then
makes sense.
calculate the area of those rectangles and just take the minimum of those. And then it would just break it down further. Oh, what's the fastest way to find all the triangle or find all the rectangles? And I think you were getting there, but it's just with that big example, it was hard and you were just spinning your wheels a bit for a while on
Yeah,
that. But yeah, and then just practice on simplifying your code. So is there ways that you can reduce all of the cases? So you're originally going to be having a ton of cases there and your for loop would have got complicated if you had any bugs in it. You would have not been able to debug it in time. So that's why I
yeah,
gave the small hint of like if it's only look for the top left and the bottom right, and if the 2 points that you have isn't the top left and the bottom right, just skip over it.
Wait, could you repeat that? Like, what was the problem with it before? Like, I get like they're both the same. I think the way that you have it, the way that you search is like a lot more cleaner.
Yeah,
Like,
because you just have
yeah,
to capture because essentially your algorithm would find the find 2 points and then you'd have to handle all the different cases. It actually might be the top light. You might have like your first for loop might actually be the top left and the bottom right, or it could be the bottom right and the top left reverse, or it could be the bottom left and the top right. Like you know what I mean? But all you really care about is the top left and the bottom right
yeah.
because uh because then you'll only check it once. Like you won't really
Yeah,
save on
I
runtime
get
with
what you mean.
all yeah. I don't know
Like,
if
if
that
like a
got clear.
bottom left and if like a top right and a bottom left exist, then like the reverse is also true. Like,
Yeah, exactly. So just wait until you
yeah,
see until you
wait,
have
yeah,
like the right points there. So for
yeah,
example, a bottom left and a top right. I don't care about those points because I'll eventually check it once I get the top left and the bottom right
yeah,
through the loop. And then I'll just check it and that saves me a lot of cases. So just simple things like that, I think in a lot of questions, you can find ways to reduce all the boundary cases or reduce all the cases. For example, when working with linked lists, you could like add in those sentinel nodes, and that reduces the boundary cases a lot.
Yeah.
And like with two pointer solutions, there's always neat tricks to reduce the boundary cases, and that was just a small one. I'm sure you would have got to it in time. I think for this one it was just working with a small example and figuring out how to solve it on a small example and then working your way up from there instead of starting with a massive example and then getting to the solution slower.
Yeah, makes sense.
Yeah. Cool. All
That's
right. Thanks for coming out.
yeah.
Appreciate you, man. Good luck on all
Thank
your interviews. You got this.
yeah. Thank you.
Yeah.
Wait,
See ya.
I feel like I represented Jane kind of poorly. I can't lie.
Nah, not really.
This
Don't
one,
worry,
this
man.
one. Wait, is this going on YouTube?
It's already up. What do you mean?
Oh, it's already up.
We're already
Oh,
live
shit.
right now.
Wait, I know we're live, but like, is it gonna be a video?
Maybe, probably. Don't worry, you did good, man. Don't worry. Be
No, there's
confident.
always. Wait, this is not the full story. If everybody thinks I'm like, if you guys think I'm
Don't worry,
like
kid. Don't
choppy,
worry. I won't post it, bro.
look at the other videos. I
Yeah,
almost said do
yeah.
a bit
No, everyone knows you're good. Yeah, I'll link all the other ones if I do.
bad
But
looks.
all right. Good luck, man.
No, but thank you. I feel like this one is pretty helpful.
Yeah.
It's like a good reminder of what I have to do.
All right. Yeah,
All
let
right,
me
I
know
really like.
if you wanna do another interview to practice like later,
Yeah, yeah.
like a
I
different
think
day.
I'll have time during the week, but I think maybe next weekend.
Yeah, yeah, yeah. I have a bunch of slots open. Just book it.
All right,
All right. Peace, bro.
all right. Thank
See
you.
ya.
I'll see you.
Yo, sorry for being late.
Yeah, I was just watching your stream only.
How was that
But
question?
yeah, means for a Jane Street guy, I think the codings would be like piece of cake. I don't know.
Yeah. Could you have done that question too? You think you would have got that one?
I think, but my approach would be different, I guess. Not the one, the diagonal checking.
Yeah. Ooh, this
Okay.
is okay. All right, so you're in.
Yeah.
Okay, I'm gonna start this up. Give me a sec. Hey everyone, so today we have somebody joining in from India. You solved 900 LeetCode questions?
Yeah, and this is my second mock with you.
Nice. Okay, this is your second mock. So how many or what questions did I ask you last time?
It was like a merge emails, and
Oh, okay.
one was easy. I don't remember the question name.
Yeah. Were you able to solve the questions?
Yeah, means I was not able to implement the DSU fully.
Oh yeah.
The
Okay.
time ran
Yeah, I
out.
remember you. I remember you. Yeah, you did pretty
Yeah.
good. Okay, let me think.
Yes.
I actually okay. Let me look through my when did you join into the stream? Have you been into in the stream for a long time or no?
Just before the last guy.
Okay. So you just saw the last guy? Okay.
Yes.
Let me get into the first question then.
Okay.
So in this question, we're going to be given an undirected tree consisting of n vertices. Each there are going to be some vertices with some apples. You need to tell me the amount of time it takes to collect all the apples, right? And walking over an edge takes 1 second. And you start at the vertex 0, and you eventually have to come all the way back to the vertex 0. So I'll post in one example, and then you could whiteboard it to tell me to see how it works. I think it'll make sense if you whiteboard it a little bit, but
Okay. So there are seven apples, right? N is equal to 7 means 7 apples
Or seven nodes.
of the tree. Yeah. So I am on the whiteboard. Yeah. So I'm thinking of first making a tree. I don't know, it is not working.
Oh, why? Just try refreshing. Or hold up. Click 7.
Okay, okay, yeah, makes sense. Okay, so these are the edges. One, four, five, to the left, three, and six. So yeah, s- so this is the edges are undirected, and edges AI BI means that exists an edge connecting the vertices AI and BI. Additionally, there is a Boolean array has apple, where has apple I is equal to true means the vertex I has an apple, otherwise it does not have an apple. Okay,
Yep.
so here 0, 1, 2, 2 has an apple,
Yep.
and 3 and 4 has an apple. So and 5 also have an apple. So yes, these three only have an apple. So I am trying to figure out how, means how the answer is coming 8. So if we start from 0, if we go 1 down, then 1 down. For collecting 4, we have to go 2 places down, right? And for collecting 5 also, we have to go 2 places down. For collecting 2, we have to go only 1 places down, so it is 5. And I think we have to return back also. Return the minimum time in seconds you have to spend to collect, and coming back to this vertex. So from 4, it will take 2 units of time to come back, and from 5 also it will take 2, and from 2 it will take 1. So basically, no, but when we reach point 1, it will take only 1 unit of time to reach back.
Yep.
So if they are same siblings, then we have to only reach the parent and we can minimize the time, right?
Mm-hmm.
So means, firstly I was thinking that it would be just the double the time to reach, means whenever we reach the apple, every time we count, and if we double the time, but that really is not the case here, because if we double the time, the answer will come as 10, but we are minimizing the time when we reach, means while going back from 4 to 1 and from 5 to 1, we will count it both as 1 second, right? And from 1 to 0, we will not count 2 seconds, we will only count 1 second. Is
Sorry,
that
could you repeat that?
so? When we are at node 4,
Yep.
while going back to 0, while going back to 1, we will count it 1, and from 5, while going back to 1, we will count 1, right?
Sure.
But from going back from 1 to 0, will we count 2 or just 1?
Well, okay. Why is this answer 8?
So for this to be answer 8, from 0 to 4, it is taking 2 seconds for me to reach 4. And for 0 to 5, it's again taking me 2 seconds to reach 5. From 0 to 2, it is taking 1 second for me to reach 2. So this comes out to be 5. Now I have to return back to my original starting node, which is 0. So from 4 to 0, it is taking 2 units. From 5 to 0, it is taking 2. And from 2 to 0, it is taking 1, right? Or I am missing something here.
Well, that doesn't add up to 8. You just said there.
Right. And that is coming to be 10. Yes. So from whenever we are reaching 1, so I am thinking that whenever I am reaching 1, I will collect all the apples in the left subtree, and then I will collect all the apples in the right subtree. So it will take me lesser time. So from 0 to 4, it will take 2 units. From 0 to 5, it will take 2 units. But while returning, I will just return from 5 to 1 and 1 to 0. So it will take 2 units only. So total will be 6 here. And while going to 2, I will go one step forward and one step backward, right?
Yep.
So it is taking 8. Okay.
Yep.
So now I understand. So while going while going in a side, we will have to take all the apples in that path and return back to the parent and go to the other side and take all the apples and then return back to the parent and to the starting node. So yeah, so firstly I think I can create a graph rather than tree. So if I go through all the means, I can create a graph where O means 0 will always be the starting point, right? Yes. Okay. So and then I can run DFS and find means if the has apple is true, means if the has apple for that node is coming as true, then I will add 2 to the answer and move forward, because 2 units will be taken to take that apple and return back to the parent node. Make sense?
Mm-hmm.
Am I missing something here? I am just looking for that part. So from 0, if I run the DFS, firstly I will come to 1, then has apple is false, then I will go to 4, then has apple is 1 here, then I will return back and I will make the resultant as 2, because 2 units of time has been taken for me to go to 4 and return back to 1. Then I will go to the right of 1, and if 5 has apple, then I will return 2 back to 1, and then I will move back with 2 plus 2 the left and right summation,
Mm-hmm.
and I think that makes sense.
Okay. So this is gonna return 4.
So means if the so means if the child of the parent contains an apple, that parent will also return 2, right? Because we are taking 2 units of time to come to that parent and traverse back to the node. Okay, so the parent should also return 2, so it should return 6 then. 2 plus 2 plus 2. 6, and here if I go to the right side, I will go to 3 means I'll go to 2 and it will return back to, no, I will go to 3, it is false. I will go to 6, it is false. But parent is true. So means if the parent, if while sending up, if the resultant value contains a value or the has apple node is true, I think we have to return resultant plus 2 while moving backwards.
Mm-hmm.
So yeah, that's what I think. So can I go ahead and start implementing?
Yeah, go ahead.
Okay. So here I define minimum time. I will take in, the input will be n edges and has apple. So I am first trying to make a tree from the edges or a graph, whatever we call it. For node comma. So it is an undirected graph, so I am appending both the directions. So now I think I have to define the DFS. I can define, I am doing defer search with node and parent. So whenever the means, firstly I need a resultant which is equal to 0. So I will go in neighbors of all the nodes. So for neighbor entry of node, so if neighbor is not is equal to parent, I have to check it is not equal to parent. So my result will become the DFS of neighbor comma node. The parent will be node, and while going back, if if the child means if res is present or has apple of node, then I will return back res plus 2 and return DFS of 0 comma minus 1. Means I think this is gonna work.
Okay, res add. If res or okay. Well, let's. Can you walk me through line by line?
Yes. Firstly, I have created a tree. Then it is an undirected graph. So I have appended both the node and the neighbor to the tree in 23 and 24. Then I have defined a DFS function. In DFS function, I have firstly defined the result, my result to be zero, because from starting the result is zero. Then I traverse to the neighbors of the graph, which is 1 and 2 for 0.
Yep.
And if neighbor is not is equal to parent, I am checking that if it is not already visited, means if it is not the parent of, means 0 1 would be connected to 4 5 and 0,
Yep.
and the parent would be 0, so
Yep.
I don't want to go back to 0 again. So resultant would be my the DFS of 1, whatever 1 is throwing. And if I so firstly I start with 0, the neighbor would be 1, then I go back again, and then it would reach 4. When I reach 4, if result, so here the result will be 0 at first because we haven't, but we find the apple at 4, so we will just return back 2.
Yep.
So here I am just checking if result, because whenever a child is returning back a parent, uh, whenever a child is containing apple and it is returning back to
Yep.
the parent, it should also, the parent should also take 2 units of time to return back to its parent. So that's why I keep on adding 2 if whenever the resultant has a
Yeah.
value.
No, it makes sense. Let's run it on this test case.
Okay.
Do you think it's gonna work on the first go?
Yes.
I see.
Yes, I think. Let's see.
10.
So it is returning 10. Okay. So why is it returning 10? Let me go through once. So firstly, if I go to um, drying, dry running my code. So firstly, if I go to 0, then it will go to 1, then it will go to 4, and 4 will return back 2, and then it will go to 5, and 5 will also return back 2, rest plus 2. So I think it will come always, it will always come additional of plus 2, because I am at last, whenever I am getting an answer, I am doing a rest plus 2. So I think it would be like a DF answer would be minus 2. And I think whenever there is no apple, I can return 0 and max of both. Yeah. Now I think,
Nice.
so because I am thinking this, because when it comes to 2,
Yeah.
uh, whenever it comes to my position where it is having the last apple and my resultant is showing the answer, it is again doing result plus 2 at the last, which is not actually required, the last iteration. So every time I think now it can work. Can you have Do you have any other example for this so that we can try? It will
No,
definitely work for this.
yeah, I think that works. I think you're fine. Let's move on to the next question.
Okay.
Sorry. Yeah, let me
So
grab it.
so means the time complexity will be order of number of nodes maybe, right? Because we are doing DFS and going through
Yeah.
each of the nodes once.
Yeah, what's your time and space complexity?
Yeah. For space complexity, it would be the number of nodes in the tree in the worst case. For means in the worst case, it would be the height of the tree, exactly the space complexity in the shack we are storing in the DFS which we are doing, and for the tree which we are means the tree which we are storing, it will be order of number of nodes and number of edges, the maximum of number of nodes and number of edges, the space complexity, because in the tree we are storing the undirected graph, and for the time complexity we are only running DFS, so we are only going through the tree once, so it is order of number of nodes.
Okay, sounds good. All right, I'm gonna ask you the second question.
Okay,
Good job.
so I did this in like 25 minutes, I guess.
Like 20? Oh shoot.
Yeah,
Pretty
so
good. Yeah.
I'm preparing for Google, so I need to be fast as.
Yeah. Okay.
Yeah.
Now this is the second question. You're given two strings S1 and S2. Find out if they only differ by the insertion of a phrase.
Okay,
When's your Google interviews?
it's scheduled for after 2 months. I have time.
Oh, you're gonna pass it easily.
No, means last time I wasn't able to. So yeah, let me go through this question. So if I'm given two strings and I have to find out if they only differ by the insertion phase. So example one is the boy goes to hospital. The cute little boy goes to hospital. Cute little is the added phase. Everything else is the same. So return true. Okay. Okay. Is nice. The girl is nice. Return false.
Wait,
Okay.
so in Google, are they gonna ask you two questions in the span of 40 minutes? Is that how it works?
Right. Exactly. Yeah.
Okay. And are you interviewing for Google India or Google US?
Google India currently.
Okay, nice. Yeah, chat's asking some questions. Okay, go ahead.
Yeah. So means it is the problem of H1B visa nowadays.
Yeah,
You must have heard.
yeah,
Yeah.
I've seen that.
So the boy goes to the hospital. The cute little boy goes to the hospital. The cute little is the added face. Everything else is the same. So return true. And for example, two, the boy is nice. Okay. So I'm thinking that if in the above case, if I change the boy to girl, it will be false, right?
In the above case, you put, yeah, it wouldn't work no more.
So means every in a string one, every means every word should be a part of string two. This is my first assumption I am thinking. So every word in S1 should be a part of S2, and means the order should also matter here, right? Means suppose I am taking one example here at the bottom. So control X. So this would be means this is not a place, but this should also return, right? Because the ordering is incorrect.
Wait, right here, the boy goes to.
64, 65.
Yeah,
Yeah, means
yeah. That
the
that that one shouldn't work.
okay. So maybe I think I can go here. I can split the words and go pointer by pointer. And whenever I find a mismatch, I can go via left pointer and right pointer. And whenever I find a mismatch, I try to move the left pointer and try to move the right pointer.
What do you mean? Try to move the left pointer and try to move the right pointer.
Okay.
That's vague.
Yes, yes. Yeah. Okay. Let me go through this example and collect my thoughts. So here would be my pointer, and here would be my second pointer. So if the here and in the second string,
Yeah,
so
four pointers.
if the word is not matching, I will directly return a false.
Okay,
Then here the and the both are matching. I move this to the second value, and here I move this again to the second value.
sure.
And these both does not match. I move, I come to the right pointer, and if these both are matching, I move both backwards, and again the and the is matching, I move again backwards. Then two and two are matching, and I move again backwards. And my first point means my left pointer should match with the right pointer. If both matches, there is an extra phase in the second pointer in the second sentence. But if both does not matches, the left and right pointer does not point to the same word at the end, that means there is more than an extra phase.
Wait, so
So here
you're gonna
goes
move
and
up. So you have like two pointers at the front. Whenever they get a mismatch, you're gonna start moving the pointers from the back.
right. And means if both the left and right pointer in the smaller string matches, means both the left
Yo,
and right
Mod, what's
pointer in
up?
the smaller string, for example in 64, if I remove the goes here, so firstly I will move the left pointer, which is the if there isn't a mismatch, I will move it to boy and the second pointer moves to cute, right? And then there is a mismatch, I move the right pointer backwards, and after two, when the right pointer points to boy in the first string and the second pointer points to little, so both the left and right pointer points to the same boy, so means so I can derive that there is only an additional phase because the left pointer is already matching to a point where we are currently at the left side and the right has reached that side. So
So this side, this would return true or false?
this would return false,
Okay.
because means the after I go here, means whenever firstly my the matches, and when I move the left pointer to boy, it does not match. So I move the left pointer back one way to back to the, because the is the only thing matching. So if I go back to the right pointer, right hospital, the and two will match. And when I come to boy, it won't match to the bottom string.
Yeah.
So the left and right pointer are both not pointing to the same words currently, so it will return false. If I remove the boy, okay, and my right pointer will point to the, and the is where the left pointer is currently and the right pointer, so I think that will return true.
Okay. Sure. All right. Go ahead and implement.
Okay. So means I am firstly moving. Will the string one will be always of the smaller size, or it can differ?
It can differ.
Okay. So here, if length of S1, if S1 is larger, I will move S1 to the second. So here I am doing the basic that every time S2 will be larger. I'm just swapping it, and then I am splitting it. I need to split it via gap. So there is one more case which is coming to my mind. If there are two gaps in between,
Two gaps.
yes. So
Well,
means that will return true or false.
what do you
So
think
suppose
based on the problem statement? What do you think?
if they only differ by the insertion of a phase, means by based on the problem statement, I think it won't matter that much, and it will still return true if there is an additional space here in line 50 and
Oh,
51,
you're
if I
saying
am
additional space.
right,
Oh,
right.
yeah, yeah. We could have just assumed that it's a proper sentence with proper spacing.
Okay, okay, makes sense. So So I'm comparing the left pointers first. String 1 of left 1 and string 2 of left 2 both are equal. Then I will just left 1 plus is equal to 1 and left 2 plus is equal to 2. Sorry, plus 1. And I will move the back pointer also. At the same time I can move. I don't need to a string of right 1 is equal to string of right 2. So it would be minus 1. So here if I go, the and the will match. Left and the right will point to 1 and 1 and it won't match. So left one and the right one would be strangled to 1. Both will end up here in 1. Going back to the right pointers. So right one hospital and hospital the 2 and it will be 1.
Like, you're did you change up your
Yes.
approach? Now you're moving both the pointers at the same time?
Yes, means I think it won't make sense to move the pointer whenever there is a mismatch. We can move both the pointers at the same time.
Okay.
Yes.
Yeah.
So right 2 will point to it will point to 0 and it will point to so if left of 1 minus 1 is equal to right of 1 anytime. Sorry, it will go it will go till 0 only. For 0 then 1, yeah, then okay, means I the will match. Left will point to 1 and left 2 will also point to 1. Boy and girl won't match, both is pointing to 1 here, 1 and 1. And for right one,
If left
boy,
one minus one equals right one, return true.
so here if string 1 of right 1 and right 2 nice is matching, then is matching, and then boy and girl is not matching, both will end up at 1 comma 1. And yeah, means I think this should work.
I mean, try running it on some the test cases.
Okay,
Well, I don't get
let's
your final conditions there. Like, Could you explain line 87 to 89?
Okay. Line 87, every time means whenever the loops gets over, every time my left would point to the position where there is the first mismatch index.
If the
Make
left
sense?
I minus 1 equals right I. Okay.
So every time my left one will point to the first mismatch index.
Okay. So
And
basically,
if
this loop is gonna stop increment or stop move like the left will stop moving in whenever it's not equal anymore, and the right will stop moving in when it's not equal anymore. So if the I mean let's run
okay,
it on
yeah,
an
yeah,
example. Yeah. Like
yeah, the left one and right one. If left one is less than the right one, the loop will stop. So every time the right one crosses the left one. Oh, yes, the loop condition should be changed. So whenever I can just make it true, loop is running if left one, then no. If left one is less than right one. So if left the both will point to one, and both worst case, no, and this loop won't work. You are right here. And means every time it is true. If left one and left two is matching, I will just keep on incrementing. If right one and right two is matching, I will just keep L, if string of string one of left one not is equal to string two of left two, means else I can just break out of the loop. I am thinking, but that won't work here too. If string whenever both are matching, I just move the pointers
yeah.
back and making sure both are moving. I just need to think of a place where the loop will stop. The loop will stop whenever the left one is, yeah, that was correct only, I think.
Well,
Less than a, yeah,
there's an infinite loop there. What if these pointer like what if those don't match at all? If left one is not equal to left two, right one doesn't equal to right two, then it just
right.
nothing ever like the point it will never left one will always be less than right one. But
Yes,
yeah.
yeah, makes sense. Yeah. So
Okay, we're pretty much at time, but maybe I'll give you 2 extra minutes.
okay.
Try
So
try to finish it off strong.
yeah. So I am thinking that if both the conditions are false, then I'll just break out of the loop. Yes, I think
Elif string.
I don't think means will it work? I'm not sure about this.
Yeah, I'm not sure. Okay, since we're pretty much at time, let's just
Yeah.
go through feedback. How do you think you did?
Yes.
How was that?
Means the first question was I think I did it nicely, but the second question was a basic but a tricky one. The ones Google asks every time. So I think I need to work on the basics once, I guess.
Yeah, this one's a. I think you. What might work if you just do this like else
Else
false,
break. Else false. Yeah.
like return that something like that, and then maybe just like return true. Would that work? If, maybe something
Yes.
like that. Maybe.
So
I think, yeah. Or Alpha saying that wouldn't work if the string. I think that would work because we have left one and left two. Those need to increment.
yeah, means
Right, there
you
might be
can
off
run
by one, but
right.
like another solution to this is pretty much one would be you just have two pointers, right? Starting from the
Right.
left and the right, or start yeah, one at the top and one at the bottom, and when they have a mismatch, move the pointer on the longer one up by like the difference between the two arrays, because then you just need to match like the latter
Right.
part.
Right.
But
Yeah. That's a nice solution. Yeah. Now I'm thinking about it. Yeah.
I think for
That's a
this, you would have you would have been able to solve all the edge cases if you were to dry run the code or like work through a small solution with the like try to dry run the code and see where it would break. Because I think you're trying to fix it and Google doesn't let you run the code. So if you're trying to fix it by just thinking through it, it's gonna take forever. So yeah, it's just dry run the code. I think you could have got it to a stage where you could just dry run the code, and then you would have seen where it went wrong, and then just fix it. But yeah, I think you did really good on the first question. I thought you were gonna do really good on the second question. You were doing pretty good. You wrote down your assumptions. You were logically working towards the solution. I really liked your solution actually, with starting with the two pointers on each end on both and moving it in. But just the implementation, you just couldn't get to
yeah.
it. So
Yeah. So what will be the verdict this time?
I
It
don't
would be
even know.
part.
It's like definitely not a fail because you did good on the first question. I think it was just to be like it would still be a higher but not a strong higher. I think
Right.
I wouldn't really dock you hard because you're just you had the right solution but your just implementation was just like 95% of the way there. But like you don't want to leave it up to chance. You want to make sure that especially when you already had the solution, just make sure that you get the code written down.
Yes.
But yeah. All right. You should schedule another one soon. These are fun. These are pretty good.
Yeah, I will definitely schedule another one.
All
Yeah,
right.
but I am thinking that it would be better if it is of system design. I am
Oh yeah.
preparing for all, so
Yeah, we'll do system design. All right, man.
and
I'll have to hop to the
what?
next person, but or what were you gonna ask?
Yeah, yeah. Means I just wanted to ask where does alpha works?
Alpha works at a unicorn company. Or no, it's public company.
Okay,
Yeah.
okay. Means he is
He's
a
pretty
nice
good.
coder. Yeah, yeah. I always see his comments while others are coding, and I find it pretty interesting.
Yeah.
Yeah, okay. I
All
will
right.
hop on
Yeah,
the
we'll see
stream.
we'll see we'll do a system design next. I'll coordinate something and we'll see how you do. Good luck.
Yeah.
All right.
Yeah.
See ya.
Thank you so much.
No problem.
Yeah.
Bye.
Bye bye.
That one was definitely a lean higher. I don't know if I would dock him because he did really good on the first question. The second question, he figured out the approach, but the implementation was a little bit tricky. And he wasn't really he wasn't really failing on weird parts of the implementation. He kind of just was failing on just the condition to when to end the loop. So it's not like there was fundamental things wrong. It's more just, and it's hard to write non-buggy code in an interview setting. So I would definitely wouldn't. It would be a lean higher for sure. Okay, we got one more guy. Yeah, that's the one thing is he did switch up his approach, which was kind of weird, but yeah, I don't think he's cheating. But yeah, I pointed it out right away too when he switched the approach. I was like, "What happened? Why'd you switch the approach?" Because usually you want to pick an approach, and then if you are gonna switch it up, you should say it. I kind of caught that he was changing his approach while he was doing it. Then I had to ask him, I was like, "Why'd you change?" But he probably just realized. So yeah, that one thing I should have said to him was, if you're gonna change your approach because you notice something better, say it explicitly. Okay, Alpha, if this guy flops, you want to do a quick one? Okay, the guy might be sleeping. Okay, I'm just gonna. Yeah, we'll do quick. We'll do quick. Okay, Alpha, I'm just gonna send you. Yeah, we'll just do a quick one. I won't even record it. Then I'll have time to go eat some food. You think you maybe give me some advice? Yeah. What do you need advice on? And Alpha, I just quickly sent you I just sent you the um, calendar invite. Let me know what you need advice on. Let me send this guy. Kunal, don't worry. I'm gonna send you the code. Don't worry. I sent you the code. Don't have to worry. Don't have to worry about it. I turned 17 trying to learn C++. I want to look towards anti-cheat and more the game route. I'm just starting. Is there anything I should know? Yeah, I think if you're just starting, just focus on the fundamentals first of C++ and programming in general. Build up a good foundation on fundamentals, like understand the language, understand all the aspects of the language, variables, all the way up to like variables, function, data types, everything related to the language, pointers, references. And then things like object oriented programming. Build up the fundamentals. Then once you have a solid understanding of the programming language and you have a good fundamentals, then you could start focusing on an area like if you want to work on anti-cheating or games. You already have the fundamentals and then you could just focus in. So I typically focus on breadth over depth. Yo, Alpha. Oh shoot. Okay, Alpha's in here. Yo, Alpha, what's up?
Yeah,
It's good. How are those questions? I feel like we had some good ones this weekend.
I feel like hold on, let me mute this stream. Okay. Yeah, I feel like they were pretty good. I was just trying to see like would I get stuck on any of them? Maybe that phrase one. It's definitely easier to think of like really good approaches if you're not coding, you know.
Yeah.
So when you're coding, you're kind of like in the moment, might not figure it out.
Yeah, that phrase one is a popular Google question right now.
Yeah.
But I think Google's asking 2 questions now. Or maybe 1 question in 30 minutes? I don't know the process.
Interesting. Yeah. I don't know if they're changing it or I thought Google was just like harder, like significantly harder, but they give you a lot of time.
Oh no, I think they just ask basically code questions. All right.
Okay.
Let's just get straight into this.
Do
The
you have a
question.
link?
Oh yeah, I'll send you the link.
Okay. I think I have it here.
Or did I send
Probably
it?
gonna flop, dude. Here it comes. All right.
I sent you the
Sorry.
link or no? Or one
I
sec.
think so. I'm joining.
I'll resend it.
All right.
Oh yeah, I sent it.
I got it. Yeah. All right.
All right, so this one's kind of practical. We're gonna be optimizing, or we're gonna be working with airport routes. So we're gonna be given an
Okay.
origin airport and a destination airport and a list of flights. You just need
All
to
right.
tell me if it's possible, or did you switch language?
I switched, I think. Oh, here it is. Yeah, it's here.
Yeah. So
Okay.
we're gonna be given an origin airport and a destination airport and a list of flights. We pretty much just need to figure out if we can actually ship a package from the origin airport to the destination airport, given the list of flights.
Uh-huh. Okay, so the flights are like start, end, and then like the start thing. Okay, I see.
It's like badly formatted. Wait, let me see. One sec. Let me give you a bit. It's gonna.
Is this like a Google one as well, or did you come up with this yourself?
Yeah, this is a Google one.
Okay. Okay, so a package starts at the original. It can only board a flight. It's greater or equal to. Task is determined it's possible to transfer the package from the origin to the destination.
Yeah.
Okay. So from NYC to SFO. Okay, I see. Okay, so all these flights have a departure and arrival time. Okay. Yeah, so definitely without, like, if you got rid of this, then this would just be like a BFS from the start one. But with the departure and arrival, it becomes a little bit trickier.
Mhm.
I'm trying to see if we can still do a BFS. Like maybe for all these different flights, they're kind of like unique, and then we treat them as separate. Let's see. So NYC, LAX. Yeah, like in this case, like, well, actually, let me just figure out. Well, let me look at the second example. So NYC, SFO. Okay, I see. Or would it be like, would it be BFS, or would it be like Dijkstra's? Like literally just Dijkstra's from the start, and then you get to cities as fast as you can. Yeah, you get to cities as fast as you can, and then once you're at a city, you try to go to, yeah, I feel like that would make more sense. So like Dijkstra's from the starting, but let me just okay. Let me just figure out here. Package arrives at LAX. Okay, so I get this, and then as far as like questions or something, I don't think there's anything here. So yeah, I guess what's the format of our inputs here? Like some kind of thing that's like string, int or something? Like some kind of object with those things,
Where?
I guess. Like what's the format of our inputs? Is it just going to be
It's
like...
gonna be a list like this. So it's maybe a string,
Uh-huh.
and then a string, and then 2 integers.
Okay.
So maybe the first element is a tuple that shows the source to destination.
Okay. Can I just say like the first or yeah, can I just like make a like some object for that or something so I can get it? So I'll just say like string start, string end, int departure, int arrival or something. Just so I don't have to do like string parsing,
Sure.
because that's
Yeah.
not really. Okay. Yeah, so I'm thinking we do like Dijkstra's, and then what do we need to do for Dijkstra's? So yeah, it's not like Dijkstra's, I guess. Let's see if this even works. So we start at the origin at time 0. And then as far as like the departure and arrival. So basically, as long as we can make the departure or something like that on time, then we are good. But yeah, if there's an edge, if we can't, then I don't think we even add it to the graph. So like if we go from like NYC to LAX, and then we go from LAX to SFO, like we can't even add that edge, right? Essentially, because like we're at LAX at 4 and we need to depart at 3. So I don't know how to make it like optimal. Yeah, I guess, can I ask, like, are there like loops? Probably. Like you can go from like NYC to LAX and then LAX to NYC or something. Like that's obviously gonna be allowed.
Yeah, there can be loops, and you could possibly get to LAX faster in different routes.
Yeah. So I wonder if we can like... like if we start our starting destination and we just like traverse those edges. So we have to know for sure like there's a path to the city we have to get to. But then we also have to figure out like, are we able to take all those edges? And probably the way to figure that out is like when we get to a city, we have to write down like what time we got there, and if we get there later, then we can ignore those. So we can say like, if we get to a city, we have to write down what time we got there, and if we get there later, then we can ignore that, right? So if we know, which is basically like Dijkstra's, like if we know we got to like LAX at time 3, we don't need to get there again at like time 10 because it would just strictly be worse. So we can have some kind of like map of like city and like earliest arrival or something.
Yeah.
And then we need the edges as well. So as
Like,
far as the edges, can we
how does
also
that-
assume that what? Sorry.
I was just saying, like, how does it affect? Like, pretend we can get to a city faster, like the fastest possible. How does that affect?
Well, if we got to a city like at time 2 and we get there again at like time 10, we can just like skip over that because like it's never going to be better, right? So it'll be like for optimization of like the algorithm, I guess.
Yeah.
Does that make sense? So we're basically just going to be like, you know, kind of like the shortest path thing. Like if we get to a city, if we get to a place twice and the second time is slower, then we can ignore it.
Yeah.
Yeah.
Like, how does that affect the options if we get there later?
Oh, sorry. Yeah. So if we get there earlier, we can like we can depart on time, right? So if we get to a city and it has like things it can go to, the earlier we get there, ideally is better, right? Like if we get ideally wherever we're at time 0, and then all the edges we can make. Like if we get to LAX at 2, for the second example, we can make the flight, but if we get there at like 5, we can't. So the optimal is just get there like as early as you can. Yeah, and then the part I need to figure out is like if we're at and for what it's worth, yeah, I think this is probably like not a 20-minute question. Maybe it is, I don't know. But if we're at some airport,
this is a 30-minute one probably,
and it has flights that we missed, then we like skip those, right? So for example, if we're at LAX at 3, we can't take this flight. So I think it's some kind of like Dijkstra's, and then whenever you get to an airport, you just check like when did I get there, and then what are all the flights I can take, and you add those to the graph. Now, when you add those to the graph, can we also assume that like if there are, or yeah, I guess are there duplicate edges? Like if there is there another LAX SFO?
No, let's keep it simple where it's just one.
Okay.
Or I mean, there could be.
There could be, right?
Affect,
but
will that affect the solution that you're mentioning?
Yes, because like if there was an LAX SFO departure at like 10, can we assume that like for the same flight, the length of the flight is the same? So like if it's like 3 to 5, it'll be 3 to 5 again. I don't know if that'll matter, but just probably good to know. It might matter. Does that make sense? Like, so if we ever have an LAX SFO flight, it'll always be the same duration. It just might have like different departure times.
Sure.
Okay, but yeah, it definitely would matter, right? Because if we have another edge, LAX, like for the second one, if we have the LAX SFO departure like 6, arrival 8, then we can make it. So yeah. Okay, so what do we need to write down like for the airport? Basically, we need to write down.
Well, actually, no. Let's not assume that. Let's assume that we won't have 2 flights at the same time, like no 2 NYC to LAX. But if they depart at different times, it could be slightly different because in real life, like.
Okay, got it. Okay, so basically what I'm trying to figure out is like what info to keep here. Like we have some airport that we're at that we add to the like let's say well actually no, yeah, I don't think it would matter. I think yeah, it wouldn't matter because basically we'd be at like NYC and we check, oh, we're at time 0, there's a path to LAX. And then we can get to LAX at 4. And if we were at like time like 0 and the departure from NYC to LAX was like 6 to 10, then we can just take that instead. So we can basically say like, okay, we're at time 0 at NYC. So then if the NYC to LAX is 6 to 10, we'd be at LAX at 10. So we can just calculate like, did we make the departure? And then the time we care about for the other one is like, so we care about airport and arrival time. And I can assume that like if we depart at 0 and arrive at 4, we can depart at 4 and arrive at 5. We can depart immediately after arrival. Like, does that work?
Yeah.
Okay.
Yeah, if we arrive at 4 and then it departs at 4,
Departure
we
is
can
at
make
4.
that flight.
Yeah. So I think the plan is basically make a map of like all the edges. Yeah, make a map of all the edges. So map like city and like edges here. And then start at city 0 at time 0 and use a heap. And then just, I mean, I don't even know if you need a heap, but for now we'll use a heap. Maybe I'll think about it later. And use a heap and just see if we can get to the end. And yeah, whenever we visit a city, we'll just mark like when's the earliest we could have been there. And if we get there later, then we can ignore those because that'll never be better. So I feel like that will work. And then we just check like if we ever got to the one we care about, if we ever get to the end, then we made it, I guess. Yeah. So does that sort of make sense? I might have to modify some stuff later on, but essentially that's my plan is like instead of a visited set, we'll have this city and earliest arrival, kind of like optimized Dijkstra's, you know, like location and like earliest time to reach.
Yeah.
And then we'll have the edges map, and then we'll just try to get there. I might have to modify a little bit, but I think that should work. So let me make some things just to make it easier because it's Java. So I'll make like this, like edge or something, and I'll just say the edge has like a string from, or like start, string, end, int, departure time, and then like int arrival time.
Like we're not going to be running anything, so you could just assume that we have.
Well, yeah, I'll just have it in this format, and then I won't be. Oh, yeah, that's right. I won't be running anything. Yeah, okay. And then I could just dry run some solutions. Okay, so we have this edge. In our heap, we're gonna have a city and an arrival time. Yeah, so we can have that as well. Like city arrival. That'll just be like string city int arrival time. Okay, I think maybe that's all we need. Yeah, I guess I won't have like a main, or I will have a main, but I won't like use it. And then I'll have a thing here, so it'll be like static. It's just a Boolean, and then departure. Yeah, we can call this like can ship package or something. So it'll take a list of edges. What else? Is that it? I think. Oh yeah, we have the origin airport as well, right? So we have a list of edges, and then we have the origin airport.
Yep.
Okay.
Yep. And edges are in the format you mentioned.
Yeah. So they'll be in this format of edge. So start end. This is basically how you can just make a tuple in Java really quickly that I found out.
Makes sense.
Okay. Yeah. So for each one of these edges, we need to add these things, and so there needs to be a slightly formatted different. So instead of edge, it needs to be like a graph edge. And this will just be like string and departure time, int arrival time. Because like if you're going from one city, you're going, well, actually, I think I can use the same thing. It's fine. It'll just be redundant. Okay, so we need to make a graph. So we need to make map string to edge graph, and this is directed. Hash map. Okay, so for edge and edges, so graph compute if absent, and this is like getter default. So we need to get the edge start. We need to make a new array list, and then we need to add the edge here. So edge. Okay, so now we have this graph. Yeah. Oh wait. Cannot infer. Oh, it's because I screwed it up. There we go. It's a list. Okay. So then we need to have a heap. And this needs to be in the format of this like city arrival thing.
Yep.
And we need to sort it by times. So this will be like a B. A. That's over. Let's see. A. Oh, what did I call it? City? Or no, arrival time. B arrival time. Okay, so we have the heap. We need to add to the heap our initial city. So new city arrival origin at time 0. And we need to mark it visited as well. So, we need to have the set visited,
Yo, Ryan,
or like
what's
the
up?
map visited that I said. So it'll be a string. And then, yeah, basically this thing right here, it's city earliest arrival. So earliest arrival will just be an integer. And this one can be called like earliest arrival.
Yep.
Okay. Then we know we can get here at 0. So earliest arrival, but origin at 0. All right. So essentially now, while we have this heap, we need to go to all the edges, and then add them in if we need to. We have in our heap, we have like the city arrival when we get there. So okay, so let's try this. So while
Do a
this
cache
is
here.
empty, it would actually be cool if it was a leak code problem and I could like run it, but I'll do that later.
Yeah.
I feel like, but that's okay. So honestly, this is like a pretty good problem. So okay, so while heap is not empty, we're gonna pop the what's in our heap? City. So like current city or something. Equals heap full. Okay, so if I guess in this thing we're supposed to have like a string destination, right? That was like the last part that I didn't mention in the input. So we have this like canship package origin destination. Okay, so if this city is, and let's get this, so this will be like actually city or cur arrival or something. So this cur city, cur arrival city, and then int time equals cur arrival.
Yeah, this is a pretty
arrival
interesting
time.
real world problem. Like ship an Amazon package. Find a
Yeah,
flight.
I feel like this would be this kind of like Amazon thing. I know they ask kind of like Amazon specific, and they really word it like in this weird way where it's like we're shipping stuff from, but it ends up being like a leak code problem. They just have like all this like backstory.
Yeah, exactly.
Okay, so basically, if the current city is the destination, then we can return true. Okay, and then now we need to go through all of the edges from this city. So far edge graph get, or it might not be in here. So get this cur city, and the default value can just be nothing. Okay, so we need to check if this edge is able to be taken. So we can say like int depart, I guess. Yeah, depart. Sure. Time. Edge. Departure time. Arrival time. Edge. Arrival time. And finally string destination. Or I guess not destination. Location or something. Edge, where is it? What did I call it? Start, end. Okay, so if the departure time is less than our current time, then we're just not able to make this flight and we can just skip.
Yeah.
Then we can also calculate like, so yeah, I guess basically then if we are able to make the flight, we're always making it at arrival time, right? There's nothing to calculate. Like we might have to wait for the flight, but we're always going to be there at the arrival time. So if so we need to check if arrival time is greater than earliest arrival at location, and our default can just be like max value or something, because then we know it for sure won't be. We can skip as well because this edge is no good. Okay, now we know the edge is good, so we're going to update the earliest arrival. Location, arrival time. We're going to add it to the heap. And so city arrival, location arrival time. And then we just return like a false at the end, and I think that's it. But let me just check, and we can dry run these like examples. So we have a graph. We have the earliest arrival heap. We have a min heap based on arrival time.
Yep.
Yeah, so we put origin at 0 because we're there right away. So we get the city, we get the time, we check if we're there, if we are, we're true. For an edge, we get the departure time, the arrival time, location. If the departure time is less than time, we miss the flight.
Yep.
If we already have the city in our heap at an earlier time, we never want to take that.
Sure.
Then if not, we update that, and then we add it into the heap. Yeah, I feel like that works. We can try it on these like examples. We can dry run if that works on like example 1 and 2. Is that good? You want me to just dry run on like the ones you have?
Yeah.
Okay.
I think it works though. The solution makes sense. Unless it like
yeah,
some of these ones are so hard to dry run. Like you're working
I mean, the
with
nice thing is yours has like 3 edges, so I think it'll be not too bad.
Yeah, let's work through the example then.
Okay. Let me actually just like I kind of know what's happening in the code, so I'm probably not just gonna go like line by line. I'm just gonna walk through what is gonna happen.
Nice.
So
I actually got this one in 20.
In 20? That's
Yeah.
pretty nuts, to be honest. Oh wait, I need a thing. I think with these ones, like you kind of aren't sure where you're gonna end up. Like you're like, oh, you might start writing stuff and then it might be incorrect.
Mhm.
Okay, so anyway, so we have these flights. So NYC. Yeah, I guess we have these flights. This is our graph. This flights is our graph. So we start basically at NYC at time 0. And so that's our heap. Then we pop from NYC, and our visited set is basically this, like NYC at time 0. We pop from NYC. We check where can NYC go to. It can go to LAX. So then we update our like visited thing to we can get to LAX at time 4.
Yeah.
And our heap will be just LAX. Then we pop to LAX, and then we can go to SFO. So we can get to SFO at 5 or 7. And then we pop SFO from our heap, and that's destination, so that works. Yeah, I mean, this one is like almost too small to really test anything, but it's fine. So this first one works. So for the second one, so we have NYC at time 0 again, and this is our heap. So just NYC heap. And then we check the edges. So NYC can go to LAX at time 4. We haven't been to LAX yet, so we update LAX 4. Then we add LAX to the heap at time 4.
Yeah.
Then we pop LAX and we see where can LAX go. We can go to SFO, but we missed the flight, so we can't go anywhere. And then our heap is empty, and then we just return false. So yeah, I think it's good.
Yeah.
And in Java too, which is like the hard part. I had to make all these freaking things.
Does this run?
So, probably not.
It's all good. Cool. How's that question? Like any comments of where your mind went that shouldn't have, or you just got there? Right
I'm still not 100% sure we need a heap, like because you just need to get there anytime. There might be something better. There might be some BFS thing, but I think with a heap, basically I went with a heap because I was like, can we do like my mind originally was like, all right, if there were no times at all, I would just do a BFS and just check like, is there a path? Maybe that's still a thing. Honestly, like just do a BFS and then skip the edges that you can't go to. Like maybe that still works in some weird way. I feel like it might, and it might be better, but I would have to like double check.
Yeah.
But I was just more confident in this. And that's also like the interview thing is like you might have two solutions and one might be better, but you're like really confident in one. And you're like, I don't want to do the one that might not work. So let me just go with the one that like I'm pretty confident in, even though it might be a little bit worse.
Yeah. I mean,
So-
what I'll tell you is, because I looked at this question already, is that,
Uh-huh.
yeah, the extras is the most optimal because, yeah, pretty much we just need to guarantee that we need to get to the airports in the earliest time because it leaves us the most options.
Right.
So
yeah.
if you just did like a DFS or BFS, like you might explore too many solutions. Like it could lead to like really exponential blow up.
Yeah.
Like
Yeah.
trying
That's
all the
possible.
different spots, like all the different ways, and then like you could maybe do a backtracking algorithm.
Like there's some BFS solutions for some problems, and I've even coded some where people
Yeah.
were like, "Oh no, you have to do heap," and I was like, "No, you can do a BFS." But it's kind of tricky, and you have to really know what you're doing. Otherwise, yeah, I can get into this. So it's not one I'm kind of like if I had DP in an interview, I would probably almost never do bottom up because I'm like,
Yeah.
well, I don't care about TLE and leak code, and I can get it completely right and top down.
Yeah.
So I would just say like, I know bottom up exists, and I know we can like space optimize or whatever. Let me do top down in like 5 minutes, and then we can optimize because I have a working solution.
Yeah.
So same kind of thing here. Like maybe I'd code this, and then they're like, "How can you optimize?" And I might think like, "Okay, let me try a BFS one now that this works." And it might work, it might not. Not 100% sure. But there are tricky. There's like all these nuances with BFS that most people don't know that do work, but they're not like something you don't really want to experiment in an interview and then be like, "Oh crap!" Like 20 lines in, it doesn't work.
Yeah.
So,
Makes sense.
yeah.
Paul's saying
Yep.
fail.
Fail. Yeah.
Oh, that's good.
Fair.
All right, man. All right. Good luck.
Bro,
with
I'm
your
a
stuff.
freaking Java expert.
Yeah, you got like I seen you get good. From
Like I feel like
your
I'm
first
better
one.
with Java. I also know all the Java internals now. And I figured out the sorted set thing isn't a Python internal, where like tree map and tree set and all this stuff is a Java internal.
Yeah.
So Java actually has more things you can use, plus you can build custom comparators for everything, which is like better than Python. So just more lines of code, but you can do a lot if you know how to do it.
Yeah. I remember when I
But
was
it is
studying
funny-
for my
Sorry, go ahead.
go ahead.
I was gonna say, so we interview people, and
Yeah.
someone even mentioned like everyone who interviewed in Java for a job failed.
Yeah.
Like you have to really know your shit. And even for some, like I just tell people like if I interview, I'm like, yeah, let me see the problem, because like some problems are going to be a disaster, and I'm not doing Java. But if it's
Yeah.
not like some nested object with like a billion types, then I can go with it.
Yeah. No, I agree. I noticed the same thing too. Like even strong candidates, they use Java and they just end up failing. I was like,
You can run out of time, yeah.
Yeah.
But I feel like I'm super fast now. Like it's more lines of code, but like, you know, I'm locked into the Java. So yeah.
oh yeah. All right, man. Good luck.
All right,
Catch you in
cool.
the next
See
one.
ya.
Peace. All right, stream. That was a fun stream. We covered a lot of ground. I'm gonna go for dinner, but catch you next weekend. We'll do more coding interviews. We'll work through more contest questions and stuff. There's a lot. But yeah. I'm gonna go eat some food. Paul, see you in next weekend. If you go into the office.
This is not my main thing, really I'm a coder. Coffee stains and imitations, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and imitations, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode,